So I think like today's probably 7.2 or 7.8 maybe. I don't know. These are kind of like I'll just go with 7.8. I'm drawing from like a really weird. I can't even reach over here. That's good enough. So I don't know. I got like, I ran the compiler. I ran the compiler a bunch of times. I had it alert only the files that are in use. So now I know exactly which files to convert. I thought it would be like 98 something, but it's like 142. That's more files than I thought, so I'm gonna just get started or whatever. I have to convert the arithmetic, the 32-bit address arithmetic to 64-bit address arithmetic, and then I have to tag the types, and I don't know, whatever. I'm gonna make a video game speed test or whatever, like a little demo. I'll make one using the browser, but I think I need to get like a standalone JavaScript to like get the browser, because there's like the web browser is a piece of garbage. It's really slow, so it's not really fair to compare another JavaScript implementation when it's tied in with the web browser. So I gotta figure out how to get. I'll figure out whatever, but I'll compare my JavaScript engine that I have now. I still have to update it to meet the I still have to update my JavaScript engine to meet the ECMA 626 or 262, whatever it is, standards, the JavaScript standards, and then it'll be more of a fair comparison for like speed test wise, whatever, and like whatever, I don't know. So until then, it's not really a fair comparison, but my engine's like a lot faster. And I'll just summarize what I just said, whatever. So like OpenGL, there's Vulkan, I don't know. I might just have to stick to the browser. I don't know, it's complicated. I'll ask Chatbot what the best solution would be, since Chatbot is supposed to be smart. I'll make some kind of test to prove that my JavaScript engine can handle making like real video games, not like shitty apps or like crappy JavaScript games, like actual C code, like speed games. And then I don't know, in the standard, whatever, the JavaScript standard, I don't know, it's things like loaded with crap or whatever. To call it a standard, as like they literally say in it, there may be memory leaks in some JavaScript implementations, such as WAML, just other JavaScripts, whatever. I'm going to like control find on the word leak. they literally say, they physically say, they actually say, they print it in text that as a standard for all implementations of this standard, and this is like the golden standard, Mozilla, Firefox, Chrome, they all look to this as the standard, like golden, like, or standards are supposed to be golden. But here's what it says in the standard. Like, I'll just have Siri read it. If Siri is going to read it, and if the sound is working, because I didn't check yet.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
I'm gonna play, I didn't hear it.
ECMA 262 15th edition, June 2000.
It's not even reading the right spot.
Page 179. One match. However, any value associated to be collected in However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
Okay, so I'll just read like the other part again.
Unlikely to be collected and could leak memory resources in implementations.
So in the JavaScript standard, they say some implementations may have memory leaks due to the lack in direction of our documentation, because our documentation sucks. That's what they basically say. But they also have a clause later, and they're like, well, here's two possible solutions, but we're not going to tell you which one to use because we really don't know in the first place, because our documentation doesn't really work. So I'll like find that spot really quick.
Weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or symbol in a manner that does not leak memory resources if, in the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms.
So there's cyclical references by nature and how this stuff is designed. They don't have a solution in the documentation because it's a huge flaw or something. My JavaScript engine has 0 memory leaks. I have weak references, but I have ways to handle it. I wouldn't call it weak references. It's all handled in place or whatever, and then it doesn't. I don't tie things into the engine that don't have to be. And I have everything really cleanly organized. And some things don't need reference counters when they're local, and everything's really managed like really good. So I don't have these issues, but all other JavaScript implementations do. So at the end here though of this clause or whatever, whatever you call it, a bullet point, footnote, I don't know. They say,
The following references describe mechanism that may be useful to implementations of weak map and weak set.
So here's what sources, whatever, where they articles where some people talk about some techniques to handle these issues that occur in high-level programming, because these high-level programmers on their high horse, they can't do low-level programming, and they have this there's something missing in their knowledge. I guess they have a lack, I guess. That's the best way to say it. So like, this document has a whole lot of lack. And I'm gonna have to like meet the standard somehow. But I'm not gonna put up with like crap. So like, it might take a little bit longer than I want. Because I'm sure there's a lot of contradictory things in this documentation. I'm gonna have to like go back and forth and like come up with a solution, because I'm pretty sure there's gonna be lots of conflict in this documentation and unresolved things that aren't going to be resolved. And I don't know. This documentation seems like a little bit of a mess. Because, I don't know. I think I explained it. So I'm gonna make like a speed test to show that my JavaScript engine can handle playing video games or making video games or like running, you know what I mean, like using JavaScript as the code for a video game. And I'll compare it to like a standalone JavaScript if I can get that to run, or I might just have to use a browser. But that's not totally fair, because the browser comes with a whole bunch of overhead of the HTML and then the DOM and then even canvas elements. They have a whole lot of overhead. Not even like related to like I want just the JavaScript engine speed and or the JavaScript engine running that I'm comparing against, and then the render times. I don't want, it's not fair to compare with all that extra overhead. So I'm gonna do that next though. First I have like 142 files to update to 64-bit, and then I'll make that test, and then I'll like test some stuff, I don't know. It'll be in 64-bit, and after that I'm gonna go through all 800 pages of this poopy standard. $804 pages of this poopy standard, and because there's a lot of poop in here. I don't know, that's about it. I'm gonna try to like talk less this stream, because I did not get anything done. I was waiting for the compiler to build. I was just talking crap. I ran out of things to talk about. It is so boring. Luckily today I don't have to click build. I don't have to wait. I have all the files I need to update, so that's what I'm gonna do. I'm just gonna get at it or whatever. So I'll have Siri read this golden standard for documentation as whatever I'm gonna turn on the computer. If the computer will turn on, it might be, who knows, I don't know. It's like really old. It's a potato. So I'm gonna turn on the potato. I'm gonna get Siri reading this documentation. And I'm gonna try to make progress. I could try, so I don't know. I'm gonna stop talking. There's something else, but next time I guess, I don't know, whatever. This phone's like dead. Like, once an iPhone gets out of date, its battery just magically, oh, it has no battery life. You even put in a new battery. You could put a new battery in an old iPhone, and it has no battery. It's really strange how that happens. I would not recommend buying a Dell computer ever. No, never buy Dell. Buy some other brand. Even like corporations. Don't buy Dell. Dell is like, oh my god. Okay, anyways, it's running. It's running for now until I get a blue screen. Bro, Dell is so bad. What kind of name is Dell? It's as bad as Alphabet. Okay, anyways. I hate everything. Oh, why is it not working? Fuck. The computer can't even boot. I'm surprised it can, like, somewhat run once it gets going. Could this please just work, just for once? Just give me a break, come on. What does it mean, no signal? It's literally plugged in. Let's try to restart, I guess. I'll just like unplug everything and plug it all back in. It literally worked like however many minutes ago, 2 minutes ago, it showed the Windows logo and it sent it over the video card. And now there's no video. I'll be right back. I can't take this.
ECMAScript 2019 introduced a few new built-in functions. Flatten flat map on array prototype for flattening arrays. Object from entries for directly turning the return value of object entries into a new object. And trim start and trim end on string prototype as better named alternatives to the widely implemented but non-standard string prototype trim left and trim right built-ins. In addition, it included a few minor updates to syntax and semantics. Updated syntax included optional catch binding parameters and allowing U plus 2028 line separator and U plus 2029 paragraph separator in string literals to align with JSON. Other updates included requiring that array prototype sort be a stable sort, requiring that JSON string if I return well-formed UTF-8 regardless of input, and clarifying function prototype to string by requiring that it either return the corresponding original source text or a standard placeholder. ECMAScript 2020, the 11th edition, introduced the match or method for strings to produce an iterator for all match objects generated by a global regular expression, import, a syntax to asynchronously import modules with a dynamic specifier, bigint. A new number primitive for working with arbitrary precision integers, promise all settled, a new promise combinator that does not short-circuit, global this, a universal way to access the global this value, dedicated exporters NS from modular syntax for us within modules, increased standardization of for an enumeration order, import meter, a host populated object available in modules that may contain contextual information about the module, as well as adding 2 new syntax features to improve working with nullish values, undefined or null, nullish coalescing, a value selection operator, and optional chaining, a property access and function invocation operator that short circuits if the value to access invoke is nullish. ECMAScript 2021, the 12th edition, introduced the replace all method for strings, promise any, a promise combinator that short-circuits when an input value is fulfilled. Aggregate error, a new error type to represent multiple errors at once. Logical assignment operators equals, and equals, weak ref, for referring to a target object without preserving it from garbage collection, and finalization registry, to manage registration and registration of cleanup operations performed when target objects are garbage collected. Separators for numeric literals, 1000, and array prototype sort was made more precise, reducing the amount of cases that result in an implementation. Defined sort order, ECMAScript 2022, the 13th edition, introduced top-level await, allowing the keyword to be used at the top level of modules, new class elements, public and private instance fields, public and private static fields, private instance methods and accessors, and private static methods and accessors, static blocks inside classes, to perform per class evaluation initialization, the X and OBJ syntax, to test for present if private fields on objects, regular expression match indices via the D flag, which provides start and end indices for matched substrings, the cause property on error objects, which can be used to record a causation chain in errors. The method for strings, arrays, and typed arrays, which allows relative indexing, and object has own, a convenient alternative to object prototype has own property. ECMAScript 2023, the 14th edition, introduced the to-sorted, to reversed, with find last and find last index methods on array prototype and typed array prototype, as well as the toSpliced method on array prototype. Added support for comments at the beginning of files to better facilitate executable ECMAScript files, and allowed the use of most symbols as keys in weak collections. V. Copyright sign, ECMA International 2024, ECMAScript 2024, the 15th edition, added facilities for resizing.
Have you ever seen a Windows phone? This is the Windows phone. You see where it says Microsoft on it, on this phone? Do you know what happened to the Windows phone? I don't think Microsoft's gonna make it. Anyways, I'm gonna try to get this computer running that runs Windows. The Windows phone. It's like it's a staple, you know. It's like a foreshadow. I wouldn't buy this phone if you're gonna get a phone. They don't make them anymore. There's a reason. I'm just saying, you know. Windows. Let's see if it'll work now. Booting should be like, it's simple. The computer just has to get going. I think it's working. I don't know, I'm gonna plug in the video card and see if it like turns off again. My bitrate's dropping, that's cool. Technology. I dropped the bitrate to 500 kilobits per second, so it should work. Who knows? I have no clue. This stuff just garbage. Oh, this is really pissing me off. Fuck this shit. God damn it. It's working. Oh my god. Okay, I'm not gonna touch anything. I'm just gonna pretend all it didn't happen, everything. I'm a happy person. This is a great day. Positive affirmations only. I'm gonna open up, get programming. I'm gonna make some progress. This be a walk in the park. A very windy park with like a large fan and very cool breeze. This would be a nice walk. Be really productive in the next 4 or 5, 6 hours. Get a lot done. Make progress. Point A to point B. Here I go. I said I because you're just watching. You need to go live your life. Don't watch this. There's no point in watching this. I'm just documenting or whatever. You need to get up and do something with your life. I don't know. Okay. So here I go. Oh, this sucks, man. I'm gonna be positive about it. I'm gonna try to be positive. I can try. Just like the Windows Phone. The Windows Phone tried. And try, it did.
Unicode.
The only reason I got the Windows Phone was because it had radio. And that's the only use it has. Is if like I'm in Traverse City and like there's no cell phone reception. I can listen to the radio. Like I can't call people, I can't text people, I can't whatever, there's no internet. But there's radio. So the Windows Phone, that's all it does. And then they like removed the radio app at some point because they shut down, they like dropped support, and there's like a third party radio app. It takes a lot of work to find and get it going. I don't know. The Windows Phone, it has one positive. If there's no cell service, and like modern, like the iPhone, it won't get reception in some areas, but there's always radio. So if you want to listen to music, you should get the Windows Phone. It's pretty nice for a radio. The browser on it, it's the world's worst browser. Nothing loads now, but it has radio, and it sounds pretty good. It does have a good sound chip. That's all it does. The camera on it sucks. I'm gonna get to work and shut up.
Unicode. Dozens of individuals representing many organizations have made very significant contributions within ECMA TC39 to the development of this edition and to the prior editions. In addition, a vibrant community has emerged supporting TC39's ECMAScript efforts. This community has reviewed numerous drafts, filed thousands of bug reports, performed implementation experiments, contributed test suites, and educated the worldwide developer community about ECMAScript. Unfortunately, it is impossible to identify and acknowledge every person and organization who has contributed to
Windows did it again. They flipped Desktop 1 with Desktop 2, even though I plugged the monitors into the same plug that they've always been plugged into. I never swapped them around. But Windows is like, Desktop 1 is now Desktop 2. So now I gotta like edit the software, hit save, load profile, and then I'll show the correct desktop. But I'm happy today. I am gonna be super positive.
editor, 12th through 15th editions. Kevin Gibbons, ECMA 262, project.
I'm gonna try to be super positive. I can't waste time today. Oh, it's not working. Come on.
//tc39.es.
And the bitrate is still dropping. So I'm gonna like set it up back to what it was, and if it fails, it fails.
//github.com/tc39/proposals blobhead finished proposals MD. Those that have reached stage 4 in the proposal process. https://tc39.es.
I'm gonna try 12,000 kilobytes per second. See if that'll work.
Practical revision since that snapshot.
It could work. Who knows?
Contributing to this specification. This specification is developed on GitHub with the help of the ECMAScript community. There are a number of ways to contribute to the development of this specification. GitHub repository, https://
At least the sound's working on this computer. That's one thing that works so far.
/github.com/tc39/
Every day's rough start here. Literally never know how it's gonna go. And once it gets going, sometimes it gets worse. Maybe I'll get a blue screen, maybe I won't. Who knows? I wish I knew.
C39/ECMA262/pools. Create a new pool.
Now it's working.
.com/tc39/ECMA2/pools/new. Test suite. Test 262. https://github.com/tc39/test262. Editors. Shuyugwa.
At least I don't have to sit and wait for the compiler to build to figure out which files are being used. That wasn't the best idea. I don't know if that saved me time or not.
Kevin Gibbon.
The amount of time it took to sit there and wait for it to build each time. I probably should have just read the code and figured out which files to open and which ones not to. The only positive is that I have absolute certainty that I won't waste time on files that don't need to be updated, because the only files that popped up are the only files that are actually being used. I don't know. That's good. So I think it did save time in the end.
https://isdiscus.org/ refer to the Carlophane for more information on how this document is created. 8. Copyright sign. ECMA in 2024. Copyright notice. 2024 ECMA International. This document may be copied, published and distributed to others, and certain derivative works of it may be prepared, copied, published, and distributed, in whole or in part, provided that the above copyright notice and this copyright license and disclaimer.
Okay. I need to think for a minute and plan out what to do.
Such as an annotated.
I think this computer's running. I gotta open up Visual Studio. I gotta save it back up. Open the text editor. I gotta organize those 141 files. 141 files. It's hard to talk with the fan. Everything gets mumbled. And I'm just gonna go through them and get them done. I want to try to get the bigger files done first, because usually I do the small files and I do the big ones, but I want to get the big ones done so I feel like I will be making more progress that way. And then when I get tired, it'll be easier to do the little files, or the files that aren't as deeply nested and complicated.
Or its successors or assigns.
So I guess I'll be right back.
On as basis and ECMA International disclaims all warranties, express or implied, including but not limited to any warranty that the use of the information herein will not infringe any ownership rights or any implied warranties of merchantability or fitness for a particular purpose. ECMA International 2024-9, ECMAScript, registered sign, 2024 language specification. Scope. This standard defines the ECMAScript 2024 general purpose programming language to conformance. A conforming implementation of ECMAScript must provide and support all the types, values, objects, properties, functions, and program syntax and semantics described in this specification. A conforming implementation of ECMAScript must interpret source text input in conformance with the latest version of the Unicode standard and ISO IEC 10646. A conforming implementation of ECMAScript that provides an application programming interface (API) that's supports programs that need to adapt to the linguistic and cultural conventions used by different human languages and countries must implement the interface defined by the most recent edition of ECMA 402 that is compatible with this specification. A conforming implementation of ECMAScript may provide additional types, values, objects, properties, and functions beyond those described in this specification. In particular, a conforming implementation of ECMAScript may provide properties not described in this specification, and values for those properties. For objects that are described in this specification, a conforming implementation of ECMAScript I support program and regular expression syntax not described in this specification. In particular, a conforming implementation of ECMAScript may support program syntax that makes use of any future reserved words noted in subclause 1.2.7.2 of this specification. A conforming implementation of ECMAScript must not implement any extension that is listed as a forbidden extension in subclause 17.1. A conforming implementation of ECMAScript must not redefine any facilities that are not implementation defined, implementation approximated, or host defined. A conforming implementation of ECMAScript may choose to implement or not implement normative optional subclauses. If any normative optional behavior is implemented, all of the behavior in the containing normative optional clause must be implemented. A normative optional clause is denoted in this specification with the words normative optional in a colored box, as shown below. A conforming implementation of ECMAScript must implement legacy subclauses, unless they are also marked as normative optional. All of the language features and behaviors specified within legacy subclauses have one or more undesirable characteristics. However, their continued usage in existing applications prevents their removal from this specification. These features are not considered part of the core ECMAScript language. Programmers should not use or assume the existence of these features and behaviors when writing new ECMAScript code. Normative optional. Point 1 Example normative optional clause heading. Example clause contents. ECMA International 2024 1. Legacy. Point 2 Example legacy clause heading. Example clause contents. Normative optional. Legacy. Point 3 Example legacy normative optional clause heading. Example clause contents. Normative references. The following reference documents are indispensable for the application of this document. For dated references, only the edition cited applies. For undated references, the latest edition of the reference document, including any amendments, applies. IEEE 754-2019. IEEE standard for floating point arithmetic. The Unicode standard https://unicode.org/versions/latest ISO IEC 10646 Information Technology Universal Multiple Octet Coded Character Set UX plus Amendment 1 2005 Amendment 2 2006 Amendment 3 2008 Amendment 4, 2008, and additional amendments and corrigenda, or successor. ECMA 402, ECMAScript Internationalization API Specification, specifically the annual edition corresponding to this edition of this specification https://www.ecma-international.org/publications-and-standards/ECMA 404 the JSON data interchange format the https://www.ecma-international.org/publications-and-standards/ecma-404 Overview. This section contains a non-normative overview of the ECMAScript language. ECMAScript is an object-oriented programming language for performing computations and manipulating computational objects within a host environment. ECMAScript as defined here is not intended to be computationally self-sufficient. Indeed, there are no provisions in this specification for input of external data or output of computed results. Instead, it is expected that the computational environment of an ECMAScript program provide not only the objects and other facilities described in this specification but also certain environment-specific objects, whose description and behavior are beyond the scope of this specification except to indicate that they may provide certain properties that can be accessed and certain functions that can be called from an ECMAScript program. ECMAScript was originally designed to be used as a scripting language, but has become widely used as a general-purpose programming language. A scripting language is a programming language that is used to manipulate, customize, and automate the facilities of an existing system. In such systems, useful functionality is already available through a user interface, and the scripting language is a mechanism for exposing that functionality to program control. In this way, the existing system is said to provide a host environment of objects and facilities, which completes the capabilities of the scripting language. A scripting language is intended for use by both professional and non-professional programmers. Copyright sign, ECMA International 2024. ECMAScript was originally designed to be a web scripting language, providing a mechanism to enliven web pages in browsers and to perform server computation as part of a web-based client-server architecture. ECMAScript is now used to provide core scripting capabilities for a variety of host environments. Therefore, the core languages specified in this document apart from any particular host environment. ECMAScript usage has moved beyond simple scripting and it is now used for the full spectrum of programming tasks in many different environments and scales. As the usage of ECMAScript has expanded, so have the features and facilities it provides. ECMAScript is now a fully featured general-purpose programming language. Point 1. Web scripting. A web browser provides an ECMAScript host environment for client-side computation including, for instance, objects that represent windows, menus, pop-ups, dialog boxes, text areas, anchors, frames, history, cookies, and input-output. Further, the host environment provides a means to attach scripting code to events such as change of focus, page and image loading, unloading, error and abort, selection, form submission, and mouse actions. Scripting code appears within the HTML in the display page as a combination of user interface elements and fixed and computed text and images. The scripting code is reactive to user interaction, and there is no need for a main program. A web server provides a different host environment for server-side computation including objects representing requests, clients, and files, and mechanisms to lock and share data. By using browser-side and server-side scripting together, it is possible to distribute computation between the client and server while providing a customized user interface for a web-based application. Each web browser and server that supports ECMAScript supplies its own host environment, completing the ECMAScript execution environment. Point 2. Hosts and implementations. To aid integrating ECMAScript into host environments, this specification defers the definition of certain facilities. For example, abstract operations, either in whole or in part, to a source outside of this specification. Editorially, this specification distinguishes the following kinds of deferrals. An implementation is an external source that further defines facilities enumerated in an XD or those that are marked as implementation defined or implementation approximated. In informal use, an implementation refers to a concrete artifact, such as a particular web browser. An implementation-defined facility is one that defers its definition to an external source without further qualification. This specification does not make any recommendations for particular behaviors, and conforming implementations are free to choose any behavior within the constraints put forth by the specification. An implementation-approximated facility is one that defers its definition to an external source while recommending an ideal behavior. While conforming implementations are free to choose any behavior within the constraints put forth by the specification, they are encouraged to strive to approximate the ideal. Some mathematical operations, such as mathexp, are implementation approximated. A host is an external source that further defines facilities listed in an XD but does not further define other implementation-defined or implementation-approximated facilities. In informal use, a host refers to the set of all implementations, such as the set of all web browsers, that interface with this specification in the same way via an XD. A host is often an external specification, such as WHATWG-HTML, HTTPS. HTML spec.org. In other words, facilities that are host-defined are often further defined in external specifications. A host hook is an abstract operation that is defined in whole or in part by an external source. All host hooks must be listed in an XD. A host hook must conform to at least the following requirements. It must return either a normal completion or a throw completion. A host-defined facility is one that defers its definition to an external source without further qualification and is listed in an XD. Implementations that are not hosts may also provide definitions for host-defined facilities. ECMA International 2024-3. A host environment is a particular choice of definition for all host-defined facilities. A host environment typically includes objects or functions which allow obtaining input and providing output as host-defined properties of the GL/OBAL object. This specification follows the editorial convention of always using the most specific term. For example, if a facility is host-defined, it should not be referred to as implementation-defined. Both hosts and implementations may interface with this specification via the language types, specification types, abstract operations, grammar productions, intrinsic objects, and intrinsic symbols defined herein. Point 3 ECMAScript Overview. The following is an informal overview of ECMAScript. Not all parts of the language are described. This overview is not part of the standard proper. ECMAScript is object-based. Basic language and host facilities are provided by objects, and an ECMAScript program is a cluster of communicating objects. In ECMAScript, an object is a collection of 0 or more properties, each with attributes that determine how each property can be used. For example, when the writable attribute for a property is set to false, any attempt by executed ECMAScript code to assign a different value to the property fails. Properties are containers that hold other objects, primitive values, or functions. A primitive value is a member of one of the following built-in types: undefined, null, boolean, number, big int, string, and symbol. An object is a member of the built-in type object, and a function is a callable object. A function that is associated with an object via a property is called a method. ECMAScript defines a collection of built-in objects that round out the definition of ECMAScript entities. These built-in objects include the global object, objects that are fundamental to the runtime semantics of the language, including object, function, boolean, symbol, and various error objects, objects that represent and manipulate numeric values including math, number, and 8, the text processing objects string and regexp, objects that are indexed collections of values including array and 9 different kinds of typed arrays whose elements all have a specific numeric data representation, keyed collections including map and set objects, objects supporting structured data including the JSON object, array buffer, shared array buffer, and data view, objects supporting control abstractions including generator functions and promise objects, and reflection objects including proxy and reflect. ECMAScript also defines a set of built-in operators. ECMAScript operators include various unary operations, multiplicative operators, additive operators, bitwise shift operators, relational operators, equality operators, binary bitwise operators, binary logical operators, assignment operators, and the comma operator. Large ECMAScript programs are supported by modules which allow a program to be divided into multiple sequences of statements and declarations. Each module explicitly identifies declarations it uses that need to be provided by other modules and which of its declarations are available for use by other modules. ECMAScript syntax intentionally resembles Java syntax. ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. For example, a variable is not required to have its type declared nor a types associated with properties, Undefined functions are not required to have their declarations appear textually before calls to them. 3.1 Objects. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based such as those in C++, Smalltalk, or Java. Instead, objects may be created in various ways, including via a literal notation or via constructors which create objects and then execute code that initializes all or part of them by assigning initial values to their properties. There is a function that has a property named.
Okay, so it's a lot of files.
New date, 2000.
I have to update them from, I'm just gonna do like whatever is in each file.
Consequences that depend on the constructor.
Oh, some of the files are really big.
Of the current date and time rather than.
I'm just gonna go from the top of the file down to the bottom. I could figure out which part of the file that's being included, but I think that'll waste me time in the end, because when I turn different build modes on and off, most of what's in that file will be included for other build modes, because I have different there's like inline caching, and then I have like hierarchical caching, and I have a whole bunch of like, there's a whole bunch of layers, whatever, and when I turn one off, I turn another one on, and most of it's grouped up in that same file, just picking different modes. So I'm gonna try to like do the whole file top to bottom, and I'll just go file by file by file, and then I'll run the compiler in between, and nothing should break until I switch it to 64-bit. If I miss something, well then I'm fucked, and it's gonna crash or whatever, because it's gonna 32-bit is 4 bytes, 64-bit is 8 bytes. Currently, even though it's a it's a software emulated 64-bit processor. The modern processor runs off software that runs on microcode inside the CPU that comes off the BIOS, and it's not magical. It's not what they claim it to be. It's why they're getting sued, lots of chip manufacturers, for selling things that aren't actually in the chip that they say it can do or that the chip contains. Anyways, I just totally lost my thought. It's gone. Oh, so even though it's a 64-bit common register value size, so it works with 64-bit numbers commonly at the CPU level for the standard common instructions like add, subtract, multiply, divide. It does 64-bit operations with 64-bit registers, even though I won't get into it. The address space only uses 6 of those bytes. The 2 bytes at the top of the 8-byte 64-bit value are not used for the address. I won't get into that. Only the bottom 6 bytes. So when I run it in 32-bit mode, it's going to use 4 bytes. When I run it in 64-bit mode, it needs 8 bytes, even though 6 bytes are only used for the address. If I run it in 64-bit mode and I missed something that wasn't updated from 32-bit mode to 64-bit mode, I lose 2 bytes because 4 bytes are used and 2 bytes are clipped, or they're lost because I multiplied by 4 instead of 8. And I'm saying 2 bytes because really it's 4 bytes are lost, but they don't use 2 bytes. So I'll just say 4 bytes. 4 bytes are lost, so like I need to make sure every single place is updated. I don't know, that's about it. It's really simple though. I just have to go through and make sure every little place is updated correctly. And then I'm good to go. So I'll like type up in Notepad or whatever. And then I'm gonna whatever get to going.
A script language and modifies the detailed semantics of some features. The strict variant also specifies additional error conditions that must be reported by throwing error exceptions in situations that are not specified as errors by the non-strict form of the language. The strict variant of ECMAScript is commonly referred to as the strict mode of the language. Strict mode selection and use of the strict mode syntax and semantics of ECMAScript is explicitly made at the level of individual ECMAScript source text units as described in 1.1.2.2. Because strict mode is selected at the level of a syntactic source text unit, strict mode only imposes restrictions that have local effect within such a source text unit. Strict mode does not restrict or modify any aspect of the ECMAScript semantics that must operate consistently across multiple source text units. A complete ECMAScript program.
So I already did this in the JavaScript files that I'm gonna have to get back to later, but I can hold off on for now.
Executing code that is defined within a strict mode source text unit in order to conform to this specification.
And then a couple days ago I was like, oh crap, I made a mistake, but I didn't yet because I thought I was doing the C files, marking things as comments, but I didn't. And it's a good thing that I'm explaining this because I would have just made that mistake. So I'm not gonna make that mistake that I was going to make. I'm really happy I just remembered this. So I'm gonna find all of these, whatever, where they're used, and then wherever it's an address related, I'm gonna replace it with an A, and whenever it's a number, like the number 4, but it's not related to the address, I'm gonna put N, and that's all I gotta do. And anything that's a comment, I'm gonna mark it with the C. I could mark it with some blah 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 comment. But I did that in the JavaScript files. And when I do Control F, I kind of want to like separate between JavaScript and C. So since I already used this tag for like the JavaScript files, I don't want to use C. I'll pick a different letter. I don't know. I have a naming convention for a bunch of things. And I can't use certain combinations of letters with underscores because it'll fuck stuff up. So whatever I name it, I have to go through and mark things as comments, address values, or just plain number values. So everywhere that this shows up, I'm going to be replacing it with this, 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 in these 141 files. 124? Oh, it's only 124. Okay, I thought it was 142, but I was just dyslexia or something. I don't know, whatever. It's close enough. So I thought it was 142. 124 is less than 142. So I'm happy because that's 24 less than I was planning on. It's like I already made progress even though I didn't start. Because mentally, that's less. I'm happy. So I'm going to go through these 124 files, replace all these with this, this, or this. And when all of these have been replaced, there's a couple more steps. I'll do that later. I have to make another define for like the size t, or what am I gonna call it? I'll call it length, I guess. So wherever it's the number 4 and it's not a cast of 4 or a type of 4, I have to use length to like, it's a different tag, whatever. So like everywhere it's a 4 byte 32-bit, it'll be 4 as length, and everywhere it's 64-bit, it'll be 8. So all these are going to be replaced with these. And then any time that there's a number that's related to an address that's a length and not a type, I'll put a length. And the comments are comments, it doesn't matter, I'll just leave them marked as comment. And then anywhere that it's a number, I'll put per length. So that's all the... There's also like a shift amount, and where I'm multiplying and dividing by. I'm gonna have a whole system of different tags, and it's gonna be overly complicated. But I'm gonna track down this, replace it. Once all of these have been removed, I'm gonna do Control F to find out how many of these exist. And I hope there's not a lot. It's probably gonna be quite a few. That was a lot. Okay, but the thing that I remembered, that I said I'm glad I remembered, like, before I started explaining, is I have things marked with, if 0 or 1, else, and if. And I have code here, whatever, and then I have code in the else. I mark things to pick I have things marked with 0 or 1, so we'll enter anyways, but the other half is still relevant because I might need to turn it on. So I need to find all of these places and then wrap them with parentheses, put a space here. I have to replace all those places with this. So as I go through, I know, oh, this code's still valuable. Instead of like look at it and think, oh, that's not important, and I accidentally remove it. So I have to kind of like sift through and make sure I'm updating only the code that needs to be updated, and I'm not missing code that should be updated but doesn't look like it's being used because I don't know, there's like a whole bunch of stuff I gotta check. I'm gonna check to see how many of these are in all the files, whatever, first.
38 method. Function that is the value of a property, 4.39 built-in method. Method that is a built-in function, 4.40 attribute. Internal value that defines some characteristic of a property, 4.41 own property. Property that is directly contained by its object. Note in addition to its properties, a function contains executable code and state that determine how it behaves when invoked. A function's code may or may not be written in ECMAScript. Examples of built-in functions include parse, int, and mathexp. A host or implementation may, note, provide additional built-in functions that are not described in this specification. Examples of built-in constructors include object and function. A host or implementation may, note, provide additional built-in constructors that are not described in this specification. Note, depending upon the form of the property, the value may be represented either directly as a data value a primitive value, an object, or a function object, or indirectly by a pair of accessor functions. Note when a function is called as a
Notepad doesn't work when you scroll down. No, not, oh no, it does. See, it jumps back up to the top. I'm gonna scroll down and it jumps back. Like, oh, it's working. It worked. Now it's working. There's a reason the Windows Phone became out of date. I think that's gonna happen to Windows too, you know. I think Windows, the operating system itself, I have a feeling that well, yeah, okay. But there's 392 files, and for this keyword, whatever that I set above, there's only 30,570 matches. So, luckily, I only have to do 100 and this scroll does not work, for fuck's sake. Luckily, I only have 124 files to do, for sure, for certain. Man, this program does not work. Fuck. And there's 30,570 I have to like go through overall, but only 124 files to deal with. So I don't know how many are in these 124 files. I could figure out later. I think I'm gonna find and replace this with this or something. I know, I gotta pick a letter. I'm using Y. I don't think I'm using U. I am using U. I might use W. I've been saving W, but I don't want to waste it on this. I'll just use W for example. So I'm gonna replace this and these 142 files, 24 files. I'll replace this with this, and I'll find out how many total, because it's gonna be less than this, and that'll give me an idea of how much I have to do. And then after that, I'll go through and I'll find all of these, because then that way only the stuff I'm working on will be tagged with this, and then I can leave these for later, but I'll replace all of these with these, and I'll get the length and place where it's a arithmetic or logical or binary operation. I don't know, that's the plan. So I think I'm gonna replace all these those files first with this, but not W. I have to pick. I have a comment somewhere where I mark off which letters I'm using for different things. I'm gonna find out what letter to use. I'll replace that first, figure out how many of these, and then it'll be easier for me to navigate through, because I don't have 30,000. Just be less than that. It's still gonna be a lot. I'm gonna get going though. So I think I'm done talking for now. Yes, I guess I'm done for now. And I need to get a pet monkey to do this for me. I don't know if you could train a monkey though to do. This is kind of complicated. And I don't think a monkey would be capable of getting the computer to run when it doesn't run. Like you might be able to train a monkey to like open a text file and like do stuff, but the monkey, I don't think the monkey would be able to figure out how to like plug in the drives, unplug one drive, pop in the BIOS battery, pop out the BIOS battery. The monkey won't know like, there's like, a monkey has like limited, I'm just wasting time when I get to work.
Grammar for ECMAScript is given in clauses 13 through 16. This grammar has ECMAScript tokens defined by the lexical grammar.
And monkeys are really creepy. I don't know. Monkeys creep me out. I don't know how people have pet monkeys. They're really, really creepy animals.
Sequences of tokens form syntactically.
No offense to people with pet monkeys, but I don't get it. It's just creepy, man. It's creepy.
Or module.
But squirrels are cute. Squirrels and chickens, those make great pets. Monkeys though, wow. It's I don't know. I don't judge. Oh, people judge me though. People love to judge me.
Script or module, with no tokens left over. When a parse is successful, it constructs a parse tree, a rooted tree structure in which each node is a parse node. Each parse node is an instance of a symbol in the grammar. It represents a span of the source text that can be derived from that symbol. The root node of the parse tree, representing the whole of the source text, is an instance of the parser's goal symbol. When a parse node is an instance of a non-terminal, it is also...
I'm gonna make a backup first. And then I'll open the compiler. Oh, I get to finally replacing. It's stretch.
Nodes are instantiated for each invocation of the parser and never reused.
I stretch and I don't feel like I stretched. I need to like really stretch, break something till something like snaps or cracks, and I'll feel like I've stretched.
String multiple times will lead to different parse nodes. For example, consider let str equals 1 plus 1 eval str eval str. Each call to eval converts the value of str into ECMAScript source text and performs an independent parse that creates its own separate tree of parse nodes. The trees are distinct even though each parse operates upon a source text that was derived from the same string value. Note 2 parse nodes are specification artifacts, and implementations are not required to use an analogous data structure. Productions of the syntactic grammar are distinguished by having just one colon as punctuation. 2. Copyright sign, ECMA International 2024. The syntactic grammar as presented in clauses 13 through 16 is not a complete account of which token sequences are accepted as a correct ECMAScript script or module. Certain additional token sequences are also accepted, namely, those that would be described by the grammar if only semicolons were added to the sequence in certain places, such as before line 10.
I can find a SATA to USB drive cable, but it's extremely slow over USB 2.0. I need to risk restarting the computer and trying to get to boot. Windows is like booting off the boot drive, but after it gets the boot logo, it seems to switch to the drive that has no operating system on it. The drive is literally an exFAT. It shouldn't boot, but Windows is like, oh, let's get going and boot to the other drive. I don't know what the fuck Windows is doing. I'm going to attempt to plug in that other drive and boot the computer again. I think I need to go on this install because I don't want to plug in a foreign USB. This computer is like isolated or whatever. I think I gotta like mark the backup drive as like non-primary or non-active for boot sector stuff. Whatever it's called. There's something in the freaking command line. I think I have to do that to drive because I think Well, I know Windows is trying to boot off it because it boots up and I get like little blinky cursor and it just stays like that. And it only does it every now and then. Sometimes it boots right, but once it does that, it gets stuck to doing that. I gotta like pull the drive out, plug it back in. I gotta restart. I can't wait for it to make a backup over USB 2.0 speeds because USB 2.0 is really slow, especially on like a legit. This computer is so fucking old. Like this is literal USB 2.0 speeds, like the bare minimum. Like they just met the standard or whatever. This computer is not fast by any means. This computer is a freaking potato. When life gives you potatoes, make potato juice. I could pick a better computer, but I'm using this computer on purpose. It's better for like optimizing code because does this say 8 megabyte cache? There is I gotta get out of this zoom magnifier.
Refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024-13. 5. 1. 5. 2 non-termina. L symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name.
It says 8 megabytes of cache. So 8 megabytes of cache, and then I can't read it from here on this other monitor. I'll go over to I have a CPU 2.8 gigahertz whatever with 32 gigabytes RAM. So with this much cache, 8 megabytes. With 8 megabytes of cache and 32 gigabytes of RAM. When you're writing a program, it's really easy. Like, instantly, you can find bottlenecks and you can write code a lot better. When you have tons of, whatever, I don't know. That's why I'm using this computer. It has to pull memory from the larger memory, and the good thing is that it doesn't get paged. It's literally like RAM, so like it's secondary memory. So it's still fast, but you can tell the speed difference, whatever, when it's the code's running smooth or not, before it gets to paging and stuff, because it has to funnel the memory from this larger pool into this tiny little pool, back and forth, whatever. I don't know. I find it easier to yeah, okay. I'm gonna like restart this computer, see if I can get it to run with the other drive plugged in, because I need to make a backup and USB 2.0 is too slow. If it doesn't work on the first try, I'm gonna take a break. I'll be back because it is so annoying to like plug stuff in, turn it on, wait, pull it out, plug it back in, pull it out, plug it in. So I'm gonna do that and I'll shut up.
Or a comma-separated list of names. A parameterized production is shorthand for a set of productions defining all combinations of the parameter names, preceded by an underscore, appended to the parameterized non-terminal symbol. This means that statement list, return statement, expression statement is a convenient abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, statement list.
Okay. When life gives you lemons, make lemonade. I should have said, when life gives you potatoes, make potatoade. Because it makes more sense. Not potato juice. I think there is such a thing as potato juice, but not potatoade. But potatoade, that sounds kind of cool. I don't know what, like, you might have to like squirt some ketchup into potatoade to make it taste a little more sweet. Because like potatoade by itself would be pretty bland, starchy, and I don't know. I'm gonna like restart this computer though, and yeah.
Is an abbreviation for variable declaration. Binder.
And I don't know if potatoade would have electrolytes, because those are like really important.
Parameter name on the reference to the current production's left-hand side symbol. For example, variable declaration in binding identifier initializer in is an abbreviation for variable declaration binding identifier initializer.
I don't think potatoes have much nutritional value. It might not be the best choice for a juice or whatever. Probably better off juicing lemons.
If a right-hand side alternative is prefixed with parameter, that alternative is only available if the named parameter was not used in referencing the production's non-terminal symbol. This means that statement list, return statement, expression statement is an abbreviation for statement list, expression statement. 6. ECMA International 2024 Statement List, return statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return, expression statement, 1, 5, 1 of. When the words 1 of follow the colon, s, in a grammar definition, they signify that each of the terminal symbols on the following line or lines is an alternative definition. For example, the lexical grammar for ECMAScript.
I click the power button and
23,450,000.
Oh man. Oh, it's working.
Which is merely a convenient abbreviation for non-zero digit. 1, 3, 4, 5.
It worked. Look at that. Oh my gosh, that's great. I feel like there's a teeny bit of hope. I have a little bit of hope now. I feel like it's gonna be a great day.
Terminals or non-terminals.
If only it did that earlier, that would have been great. But now it's working. So I'm gonna be happy now. I'm gonna make it back up, open up the compiler, and I'm gonna get going.
May only be used if the token sequence sec is a.
Because at any minute, I could get a blue screen. This is like a 15-year-old potato. So I'm gonna get going before I get a blue screen.
The prefix of the immediately following token sequence. For convenience, the set can also be written as a non-terminal, in which case it represents the set of all token sequences to which that ECMA International 2024-17 non-terminal could expand. It is considered an editorial error if the non-terminal could expand to infinitely many distinct token sequences. These conditions may be negated. Look ahead sec indicates that the containing production may only be used if sec is not a prefix of the immediately following input token sequence, and look ahead set indicates that the production may only be used if no element of set is a prefix of the immediately following token sequence. As an example, given the definitions, decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal digits. Decimal digit. Decimal digits. Decimal digit. The definition. Look ahead example. N. Look ahead. 1, 3, 5, 7, 9. Decimal digits. Decimal digit. Look ahead decimal digit. Matches either the letter N followed by one or more decimal digits. The
it flipped around the monitors. Again. Why does Windows keep doing this? Just make display number 1, display number 1. And let display number... Oh, it's... Give me a warning. Okay, so... No, never mind.
It is considered an editorial error for a token sequence sec to appear in a look-ahead restriction, including as part of a set of sequences. If the choices of lexical goal symbol
Is this program stuck?
token sequence, 1, 5, 8, no line terminator here. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position.
Okay, I don't know. I made my backup, so I'm gonna get going. After I open up this screen pixelizer for the other desktops.
The presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the script, 1, 5, 9 but not. The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word.
To the desktop switch again. What the heck?
Points that could replace identifier name provided that the same sequence of code points could not replace reserved word. 8. Copyright sign. ECMA International 2024. 5. 1. 5. 1 0 descriptive phrases. Finally, a few non-terminal symbols are described by a descriptive phrase in sans serif type in cases where it would be impractical to list all the alternatives. Source character. Any Unicode code point to algorithm conventions. The specification often uses a numbered list to specify steps in an...
Okay, somehow this desktop 1 is desktop 2, and on this desktop 2 is desktop 1. I'm not going to question it. I'm just going to go with it. It's probably going to cause some bug to let the computer run when it's confused. But I don't want to restart again because it looks like it's almost working. And almost working is good enough for me. Because it will never work fully. This is by Windows. It's designed by the people that developed the Windows Phone. And we all know what happened to the Windows Phone. Because nobody had a Windows Phone. Except the people that had one. And they know what the Windows Phone was. The Windows Phone.
Some steps are indented.
A cell phone. Developed by Windows. Hardware, software, the whole thing. The entire phone. They bought Nokia. They bought several companies. They developed a cell phone. They spent so much money. It was billions. I don't remember how much exactly. I think it was 6 billion, 4 to 6 billion, something like that. They spent that much money to develop the Windows Phone. It's a Windows Phone.
Steps. In this case, the substeps are only applied if the predicate is true. If a step or substep begins with the word else, it is a predicate that is the negation of the preceding if predicate step at the same level. A step may specify the iterative application.
I can't wait for Windows 12. It's gonna be great. Literally Windows 12. It's gonna be the best Windows ever. It's gonna be amazing.
Such assertions add no additional semantic requirements and hence need not be checked by an implementation. They are used simply to clarify algorithms. Algorithm steps may declare named aliases for any value using the form let x be some value.
It is better than Windows 95. Windows 95 was horrible. Why is this program not opening?
Creates a shallow copy of some value. Once declared, an alias may be.
Windows 95 is completely, like, it's beyond unstable. And if you connect Windows 95 to the internet, oh my god, the drive it's just filled with viruses, and then it crashes. Like, you get like the screen melts, and like it's literally open. It's like a host for viruses if you connect a Windows 95 computer to the internet. Like, you don't even have to go on the internet. People put like Trojan horses and all the downloads. I even have like an original 95 download. I had to like, it's a lot of work, whatever. I got on the internet and then I got viruses right away. It's just like, whatever. Windows is a joke.
Value operation name.
I'm gonna stop now. I'm just gonna get to work.
A syntax-directed operation is a named operation whose definition consists of algorithm.
Windows talks about security and stuff. Right. Security.
Alternative definitions will typically have a distinct algorithm for each alternative. When an algorithm is associated with a grammar production, it may reference the terminal and non-terminal symbols of the production alternative as if they were parameters of the algorithm. When used in this manner, non-terminal symbols refer to the actual alternative definition that is matched when parsing the source text. The source text matched by a grammar production or parse node derived from it is the portion of the source text that starts at the beginning of the first terminal that participated in the match and ends at the end of the last terminal that participated in the match. When an algorithm is associated with a production alternative, the alternative is typically shown without any grammar annotations. Such annotations should only affect the syntactic recognition of the alternative and have no effect on the associated semantics for the alternative.
Actually, let's say I want to update Windows whatever, so I'm on Windows whatever. I'm gonna update Windows here. I'm going to complete updates to help keep my device secure. Your device is missing important security updates. Make sure to keep your device plugged in so Windows can update. So I'm going to retry it all. And then I'll download. It's downloading, but it says 0% because it's not plugged in. And then I'll retry all, and then download. Get device updates. I'm gonna turn this off. It is already off. So I wanna download these updates right here. You see it says I need a 2025 cumulative update for Windows 11, blah blah blah. And I need this update here, so they know which updates I need, because they're right here. So I'm going to download and install them here, and then there we go. It's downloading, and then it's just gonna get stuck going the loop. I want to know how to turn this off because it's annoying. Like, they like loaded up before I wasn't on the internet what I need to like hound me later with, you need this update. And then like I can't get rid of this stupid pop-up. It just won't go away. I'm gonna look into it later because it's annoying. It just keeps popping up in the corner. But like, for them to, I don't know, secure, I don't know. Windows isn't known for security, and I'm like, 9,000% sure that doing any form of update with Windows is going to make anything, if not less secure. I have to stop going on random rants and just get working.
If hygienic.
So I made a backup, and I'm gonna open the compiler. I'm gonna go through 141 files, whatever. I think I'm gonna organize them first. That's what I'm gonna do. And then I'll deal with replacing stuff, whatever. Try to open things up, figure out what I'm getting into, and then do it.
Completion, argument, else. Set argument to argument. Let result be abstract operation, argument, 2, 3, 4 return of abrupt shorthands, invocations of abstract operations and syntax-directed operations that are prefixed by indicate that return of abrupt should be applied to the resulting completion record. For example, the step ? Operation name is equivalent to the following step, return of abrupt, operation name. Similarly, for method application style, the step ? Some value operation name, ECMA International 2024-21 is equivalent to return of abrupt, some value operation name. Similarly, prefix is used to indicate that the following invocation of an abstract or syntax directed operation will never return an abrupt completion and that the resulting completion records field should be used in place of the return value of the operation. For example, the step let val be operation name is equivalent to the following steps. Let val be operation name, assert val is a normal completion, set val to val. Syntax-directed operations for runtime semantics make use of this shorthand by placing or before the invocation of the operation. Perform syntax-directed operation of non-terminal 5, 2, 3, 5 implicit normal completion in algorithms within abstract operations which are declared to return a completion record, and within all built-in functions, the returned value is first passed to normal completion, and the result is used instead. This rule does not apply within the completion algorithm or when the value being returned is clearly marked as a completion record in that step. These cases are when the result of applying completion, normal completion, or throw completion is directly returned. When the result of constructing a completion record is directly returned, it is an editorial error if a completion record is returned from such an abstract operation through any other means. For example, within these abstract operations, return true means the same things as any of return normal completion, true, or let completion be normal completion, true, return completion, completion, or return completion record, normal, true, empty. Note that, through the return of abrupt expansion, the following example is allowed, as within the expanded.
Okay, now it doesn't look that bad. It's not that many files.
Wrapping in the normal case, return completion. The following example would be an.
It's still files.
24, 5, 2, 4 static semantics. Context-free grammars are not sufficiently powerful to explain.
Oh my god, it can still click. That's amazing. I have found the first use. I'm actually really happy right now. Apparently, I can control find in Sublime, and it gives the file path whatever. And when I pasted them back, I got rid of all the code between. The links, they still work. This is going to save me a lot of time. I didn't think this would work. I had a feeling it might, but I've never tried it because I never had to do this many files in a chunk. But it looks like I can actually click these. Oh, this is great. So I can actually organize these over here and then regroup them. And then I can click on them. Oh, this is gonna be nice.
Implementation must, prior to the first evaluation.
It might actually be like a walk to the park. I can organize this stuff. into little groups. And then I can put little comments, mark shit up, tag things, organize things. And I can go through each group and then pick on it, and it's actually going to find the file and open it for me. So I don't have to open up the Explorer and freaking copy, open the freaking file, Explorer, paste, enter, because that takes so long. Okay, knowing this, I'm gonna go think. I'll be back. So I'm gonna like I'm gonna search for all these, whatever. I'm gonna replace them with I think W. I'm gonna double check. I'm gonna pick a letter I'm not using already, because I don't want the names to mangle. I'll replace all of these with all of these. For all of these files, 124 files, whatever. And then I will be able to Control F, find all of these, and I'll get a realistic number. It's not going to be 30,000, it'll be less than that. But then I'll have some kind of idea of how much work I have to do. And then I'll sort these by, I'll put the more complicated ones on top, the easier ones on the bottom. And then I'm going to go through and replace all of these with the type, if it's address or number, and then any size that I find as I'm replacing those. I'm going to put in if it's address length or a number length. And after this process of going through everything and replacing, I will be done, and this will be a 64-bit program. I think I have like 7 days left. I'm not gonna make it. I don't know, I'll make it close. This is all that's left, I'm done. At that point, I'll get OpenGL, Vulkan, I don't know, DirectX 11. I gotta figure out which is like the easiest to run in the browser. If I can get off the browser, I won't use the browser. I'm gonna make a comparable speed test between a couple JavaScript implementations and my implementation, and show which one can do more number crunching, video game logic wise, between frames, and keep a stable frame rate, to show that this can handle, my JavaScript engine can handle making like C quality video games. It's more like a comparison to C++, but it's not, it's JavaScript. It's probably because like it's gonna run kind of like C++ speeds basically, because C++ has overhead, but it's not plain C. And this is plain C, but I know it's complicated. There's no C++ at all in any of this. It's all just vanilla C and freaking ancient system file calls that I'm gonna have to replace with the newer system file calls at some point. But I don't want to do that now because it's gonna take work to like rewrap all the the file access calls with the new shit. The new stuff is, I don't know, whatever. I don't know, that's it. There's one last thing.
Will be described as either inclusive or exclusive, but not both. There are 4 kinds of intervals, as follows. An interval from a inclusive to b inclusive, also called an inclusive interval from a to b, includes all values x of the same numeric type such that a xb, and no others. An interval from a inclusive to b exclusive includes all values.
I can't remember. After that, I'll prove that's fast or whatever. Then I'm gonna go through these I'm gonna call them golden standards because standards are supposed to be golden. So this is a golden standard. I might have to check other standards after this, but this is like everybody glorifies the standard. It looks the nicest out of them. Someone put time into color coding it and stuff. There's other standards that are like basic text files, so at least this one looks nice. It looks nice, you know. At least it looks nice. But I'm gonna meet the standard without the bugs that they consider acceptable and literally say exist in some implementations. I'm not gonna have those and stuff. But after I meet the golden standard, I'm planning on 2 months for this standard here. That's really optimistic now that I look at it. I spent a year making a memory manager program to like deal with small allocations of memory that I'm gonna sprinkle throughout this program, which is why I have like 2 programs. I'm trying to like merge them into one, and I have other stuff from other things that I'm gonna throw in from the past, like time scheduling and threading and stuff. Except I have to tweak those to also to meet the standard. So there's fine tuning I have to do to meet this stupid standard, but it will be 100% compliant. Oh, that's what I was gonna say. But then after this thing is all compliant, I'll be able to run like a final comparison between my JavaScript engine and other ones. And it should still be faster than other current JavaScript implementations. Because even when I add all this stuff to the engine to bloat it down. Wow, that was weird. Like just like cut out.
Values for specification values.
Even when I add all these features, whatever, if you want to call them features.
Mathematical values and extended math. Unicode code points, enums, abstract operations, including syntax-directed operations, host hooks, etc., and ordered pairs. Examples of specification values with specification identity include, but are not limited to, any kind of records, including property descriptors, private elements, etc., parse nodes, lists, sets and relations, abstract closures, data blocks, private names,
like this here, whatever.
specification identity agrees with language identity for all ECMAScript language values except symbol values produced by symbol. 8.4. To static semantics is function definition. The syntax-directed operation is function definition takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A.
I think that's a function call. I'm gonna double check really quick. Man, I hit the wrong button. Let's check on it. Why is this in the documentation if it's not even used? I'm gonna have to like dig through this documentation. Is this like an internal thing maybe? The string prototypes are pretty straightforward. So I'll find one of those, for example. I can't waste time on this explaining stuff. Okay, so like string prototype dot local compare.
V8 inline cache, Google search, V8 JavaScript. The locale compare method of string values returns a number indicating whether this string comes before or after, or is the same as the given string in sort order. In implementations with Calculator API.
Oh my god, it does all that? What?
The locale compare. The locale compare method of string values returns a number indicating whether this string comes before or after, or is the same as the given string in sort order.
What the fuck kind of function is that? Oh my god. They should make 3 separate functions. Oh, this is gonna be fucking hell. Okay, basically. Fuck, this is stupid shit. So whenever I meet, and I have all these stupid, bogus, ridiculous, dumb, icky, it gives me the ick whenever I meet this standard by having all these things available. I basically just need to like add a module called .prototype and then a function called local compare, and the current engine as it is as it is. I don't have to change it. I can sprinkle in this new program I have to memory map these new things that will hold all these like little pieces of memory and all these like this shit basically. So I have the engine, it's fucking squeaky clean, it runs like a bat out of hell, and I'm gonna have to put this shit in here. Like, I don't know what kind of function this is.
The locale compare method of string values returns a number indicating whether this string comes before or after, or is the same as the given str. Same as the given string in sort order.
This function sounds like it doesn't know what it wants to do, so it does several different things. It's gonna be a pain to like account for all that. I'm pretty sure lots of stuff in the documentation is just like this, and it's like logically inept. They should have 3 separate functions, not like a function that does a little bit of everything. But okay, anyways, once I meet all of this stuff, all I'm going to be doing is adding, like sprinkling through this other stuff to meet this standard. This golden standard here. Oh, this is so annoying. I can't believe this sucks. Once I meet the standard, I get all these things sprinkled throughout, and it literally does everything that all the other JavaScript implementations can do. It should run at the same exact speed. And these things, whatever, these little add-ons, these icky, yucky, little, whatever. I don't want to call these things like enigmas, because that's kind of a compliment. I'll call them something later. Whenever I add all this shit to the engine to make it compliant, the engine will still be the same speed. And if I don't even have to heavily optimize these things, because they're gonna be really fast. It's in C code. I have like no overhead of virtualization or jig compilation. It does compile once and then it runs. So there is compilation overhead. That's relevant right now. That's like a whole other thing. This is really complicated. I'm trying to make it sound simple, but once I meet all this stuff, I get all stuff added in, the engine will still be fucking fast. This stuff will be fast too once I sprinkle it in. I'm not going to optimize anything until the very end. I'm going to just leave it as it is, put the new stuff in. That'll be like the chapters. I'll change from prologue down here in the bottom corner on the video. I'll change it to chapter or something. And then I'll have an epilogue. And in the epilogue, I'm going to go through and I'll optimize whatever these things that seem to be slow or that need to be sped up. And I'm going to fine tune the whole thing. I don't know, prepare for release and stuff. But after all that, it'll be fully compliant. I can compare basically at that point apples to apples that my JavaScript engine can be used for real video games. Because it should run at the same speed. Even with all stuff sprinkled in, it will affect the code. And if these things are called and used, it's gonna impact performance. It could actually, in fact, like, detriment performance if it's like all over the place in the code, and if it's like in the code, like it could fuck up all the cache lines that I have, or not that I have. It could fuck up how I have things set up because it'll eat up the cache and it eats up code memory. So I may need to like set up jumps and stuff and figure out how to make sure the compiler puts this stuff like in different areas so like all the engine code that I have will be able to be packed really tight, so when it's called and run, it's going to be in the cache, or more likely be in the cache. So all this stuff is like complicated, whatever. But at the end of all this, I'll be able to compare the two, and I'm like 9,000% sure that, I don't know, my engine will still be like basically the same. If anything, like a teeny bit slower, but not very much. And totally capable of handling like actual like video games. Oh, that's what I was gonna say. So, like earlier when I forgot. So my JavaScript engine, whatever, if you have a computer, which you need to have a computer to run any kind of program, obviously, and you make a video game with whatever, my JavaScript engine, whatever, however much RAM you have, if you have 32 gigs, if you have 120 gigs, if you have 256 gigs, if you have 512 gigabytes of RAM. Since I'm updating it to 64-bit support right now, I'm going to get to that after I'm done talking. I just wasted a whole bunch of time. This program will be able to use all of the memory. And once I add in threading, I'll be able to use all of the threads. Except, technically in the documentation, threading in JavaScript is done kind of weird. So I'm going to have to meet that standard, but I'm going to have to make an exception. I'll put a keyword or something so you can enable actual multi-threading that doesn't meet the standard, but it'll be like a toggle so you can turn it on and off. So when I meet the standard, it really, I don't know, whatever. Everything is circumstantial and conditional, but I'll figure out a way to like have it all in there. But then you'll be able to have access to all the RAM, all the threads, whatever. But the OS will be limiting performance and how your program runs, so you really don't have access technically. Whatever's available should be available though. And then you could like you could do number crunching. That's why I used this for originally. Not number crunching, but something like that. Works with lots of numbers, whatever. I don't know. It's really powerful. It can do a lot of stuff. I'm just like selling it as video games because that's the only thing that most people do on the computer, like encryption or data compression or like it'd be better for those things, but nobody does those things. So I'm selling it for video games because everybody plays video games. And video games are where it's at, clearly. So, I don't know. It can do way more than that though, but I'm gonna say video games. So I think that covers everything. And I'm gonna close this. So after I get this converted, I get some, like, actual tests. It's not gonna be like I'm talking to my ass, it'll be like proof, whatever. I really don't prove myself ever. I really don't care what people think. But I just gotta show something, whatever, to like, for me to keep saying stuff. So after I convert it, I'll do that. I don't know, that's the whole plan, whatever. So I will get back to this in a minute. I'm gonna go think. I'm gonna like open these files. I'm gonna replace that keyword, like I said earlier, for all these files. I'm gonna go through them, whatever, one by one. I'm gonna organize them. Luckily, I can like split these up, and they still click the links. That's gonna save me a ton of time. So I'll be back, and then I'll approach this, and I'll take a head on. I'm gonna try to get as much done as possible. I could possibly get this all done in 7 days. And I'll be able to get to this documentation. And then meet all these amazing, beautiful standards that make no sense, but I have to meet them, so it's compliant. And I'll have my own stuff to make sure, like, it does what I wanted to do, and it actually, I don't know, whatever. I'll be back. I need to, like, kind of play stuff out. So, BRB.
A concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Turn top level lexically declared names of statement list. Note 2: the lexically declared names of a module includes the names of all of its imported bindings. Module item list. Module item list. Module item. Let names 1 be lexically declared names of module item list. Let names 2 be lexically declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Return the bound names of import declaration. Module item. Export declaration. If export declaration is export variable statement, return a new empty list. Return the bound names of export declaration. Module item. Statement list item. Return lexically declared names of statement list item. 2.5 Static semantics. Lexically scoped declarations. The syntax-directed operation lexically scoped declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be lexically scoped declarations of statement list. Let declarations 2 be lexically scoped declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return lexically scoped declarations of labeled statement. Note 1 at the top level of a script. Function declarations are treated like var declarations rather than like lexical declarations. Note 3 at the top level of a module. Function declarations are treated like lexical declarations rather than like var declarations. Return a new empty list. Statement list item. Declaration. Return a list whose sole element is declaration part of Declaration 98. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the lexically scoped declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be lexically scoped declarations of default clause. If the second case clause is present, let declarations 3 be the lexically scoped declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses case clause. Let declarations 1 be lexically scoped declarations of case clauses. Let declarations 2 be lexically scoped declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically scoped declarations of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration 1. Return function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. ECMA International 2024-99. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Module. Empty. Return a new empty list. Module item list. Module item list module item. Let declarations 1 be lexically scoped declarations of module item list. Let declarations 2 be lexically scoped declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Export declaration. Export from clause. Export named exports. Export variable statement. Return a new empty list. Export declaration. Return a list whose sole element is declaration part of declaration. Export declaration. Export default hoistable declaration. Return a list whose sole element is declaration part of hoistable declaration. Export declaration. Export default class declaration. Return a list whose sole element is class declaration. Export declaration. Export default assignment expression. Return a list whose sole element is this export declaration. 00 ECMA International 2024 8 2 6 Static semantics. var declared names. The syntax-directed operation var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement. Return a new empty list. Block. Return a new empty list. Statement list. Statement list item. Let names 1 be var declared names of statement list. Let names 2 be var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration 1. Return a new empty list.
Variable statement, variable deklaration list. 1. Return both names of variable deklaration list.
If statement, if expression statement, else statement. Let names 1 be var declared names of the first statement. Let names 2 be var declared names of the second statement. Return the list concatenation of names 1 and names 2. If statement, if expression statement 1. Return the var declared names of statement. Do while statement, do statement while. Expression 1. Return the var declared names of statement while statement, while. Expression statement 1. Return the var declared names of statement for statement 4. Expression not statement 1. Return the var declared names of statement for statement 4. var variable declaration list. Expression not statement. Let names 1 be bound names of variable declaration list. Let names 2 be var declared names of statement. Return the list concatenation of names 1 and names 2. ECMA International 2024 101. For statement 4. Lexical declaration expression not statement 1. Return the var declared names of statement for in of statement 4. Left-hand side expression in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. For declaration of assignment expression statement for await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement, return the var declared names of statement for in of statement 4. var for binding in expression statement 4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let names 1 be the bound names of for binding. Let names 2 be the var declared names of statement. Return the list concatenation of names 1 and names 2. Note this section is extended by an XB 3.5 with statement with expression statement 1. Return the var declared names of statement. Switch statement. Switch. Expression. Case block 1. Return the var declared names of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let names 1 be the var declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be var declared names of default clause. If the second case clauses is present, let names 3 be the var declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clauses case clause. Let names 1 be var declared names of case clauses. Let names 2 be var declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1. 2. If the statement list is present, return the var declared names of statement list. Return a new empty list. 02. ECMA International 2024. Default clause. Default. Statement list opt. If the statement list is present, Return the var declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var declared names of labeled item. Label. Led item. Function declaration. Return a new empty list. Try statement. Try block catch. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Return the list concatenation of names 1 and names 2. Try statement. Try block finally. Let names 1 be var declared names of block. Let names 2 be var declared names of finally. Return the list concatenation of names 1 and names 2. Try statement. Try block catch finally. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Let names 3 be var declared names of finally. Return the list concatenation of names 1, names 2, and names 3. Catch, catch, catch parameter, block 1. Return the var declared names of block. Function statement list, empty, 1. Return a new empty list. Function statement list. Statement list. Return top-level var declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top-level var declared names of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. ECMA International 2024 103. Script. Empty. Return a new empty list. Script body. Statement list. Return top-level var declared names of statement list. Module item list. Module item list module item. Let names 1 be var declared names of module item list. Let names 2 be var declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return bound names of export declaration. Return a new empty list. 2.7 static semantics. Var scope declarations. The syntax directed operation var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement. Return a new empty list. Block. Return a new empty list. Statement list. Statement list item. Let declarations 1 be var scope declarations of statement list. Let declarations 2 be var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Declaration 1. Return a new empty list. Variable declaration list. Variable declaration 1. Return variable declaration. Variable declaration list. Variable declaration list. Variable declaration. 2. Let declarations 1 be var scope declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration. 04. ECMA International 2024. If statement. If. Expression statement else statement. Let declarations 1 be var scope declarations of the first statement. Let declarations 2 be var are scoped declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement. If. Expression statement. Return the var scope declarations of statement. Do while statement. Do statement while. Expression. 1. Return the var scope declarations of statement while statement. While. Expression statement 1. Return the var scope declarations of statement for statement. 4. Expression not. Expression not. Expression not statement 1. Return the var scope declarations of statement for statement. 4. Var variable declaration list. Expression not. Expression not statement. Let declarations 1 be var scope declarations of variable declaration list. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2 for statement. 4. Lexical declaration expression not. Expression not statement 1. Return the var scope declarations of statement for in of statement. 4. Left-hand side expression in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement, return the var scope declarations of statement for in of statement. 4. var for binding in expression statement. 4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB. 3.5. With statement. With expression statement. Return the var scope declarations of statement. Copyright sign. ECMA International 2024 105. Switch statement. Switch. Expression. Case block 1. Return the var scope declarations of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the var scope declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clause is present, let declarations 3 be the var scope declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the var scope declarations of stat element list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var scope declarations of labeled item. Labeled item. Function declaration 1. Return a new empty list. Try statement. Try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch. Catch. Catch parameter. Block. Return the var scope declarations of block. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the top level var scope declarations of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var scope declarations of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var scope declarations of statement list. Module. Empty. Return a new empty list. Module item list. Module item list module item. Let declarations 1 be var scope declarations of module item list. Let declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107. 8. 2. 8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top-level lexically declared names of statement list. Let names 2 be top-level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation.
I explained everything before this, and I'm gonna try to make these 124, 42, whatever it was, file names, whatever, into a comma separated list. I'm gonna see if the compiler will find and replace. I'll do a mass find and replace on the keyword first. And then I'm gonna go through and try to organize these, and then I'll get to converting things. And it's a good thing that I explained everything earlier, because I would have forgotten about all the preprocessor stuff with the ifs and the comments and stuff. I don't know. It's a good thing I went through all that, because if I would have just went into working, I would have forgot about things, and then I'd be like, oh shit, I messed this up. But I have it back up, and I have went through everything. I kind of have a direction now what I'm gonna do. Kind of plan out later. I gotta look up how to get what to use, whatever, for 3D rendering to compare, whatever. I don't know. I'll see if Chatbot can give me some useful info on that, because it might actually be kind of useful, better than Google. So I'm gonna replace the keyword. I'm gonna organize this stuff and stop talking for a bit. I gotta try to get something done today, because I don't have to wait between the compiler building and I got all the files, and I'm gonna get going.
Let
super exciting, super fun. I'm gonna stay positive. Try to stay positive and make some progress.
1 and declarations 2.
I'm in like a win-win situation here. Or, like, normally I'll put myself in like a lose-lose situation, and then I come out like somewhere in the middle, like by the skin of my teeth. I'll like be like, it's not a loss, it's definitely not a win, but I didn't lose. It's like, how'd you not lose? But this situation I'm in with this stuff, whatever, this is a guaranteed freaking win, 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 win. The only way I can mess this up, it's not possible to mess it up. I'm like guaranteed whatever. So I'm like extremely happy. I don't know. So I'm gonna get to this and get as much done as possible today.
109. 8.
I'm really glad that I did this like 8 years ago, 7 years ago. I don't know. I have I don't know. This is gold. I don't know. Whatever. This is I didn't plan to sell it. I was just doing it for myself. Whatever. Okay, none of that matters. I don't know. I just gotta update it. It's done.
Duplicate labels of statement list with argument label set. If his duplicates is true, return true. Return contains duplicate labels of statement list item with argument label set. If expression statement else statement, let has duplicate be contains duplicate labels of the first statement with argument label set. If his duplicate is true, return true. Return contains duplicate labels of the second statement with argument label set. If expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, for. Expression statement, for. var variable declaration list. Expression statement for. Lexical declaration expression statement, return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement, for. Left-hand side expression in expression statement, for. var for binding in expression statement, for. For declaration in expression statement, for. Left-hand side expression of assignment expression statement, for. var for binding of assignment expression statement, for. For declaration of assignment expression statement, for await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement, for await. For declaration of assignment expression statement, return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement, with expression statement, return contains duplicate labels of statement with argument able set, switch statement, switch, expression, case block, return contains duplicate labels of case block with argument label set, case block, 1. Return false, case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, then, if contains duplicate labels of the first case clauses with argument label set is true, return true. If contains duplicate labels of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses, case clause. Let has duplicates be contains duplicate labels of case clauses with argument label set. If his duplicates is true, return true. Return contains duplicate labels of case clause with argument label set. Case clause, case expression, statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause, default statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. If contains duplicate labels of block with argument label set is true, return true. If contains duplicate labels of catch with argument label set is true, return true. Return contains duplicate labels of finally with argument label set. Catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list. Module item list. Module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax-directed operation contains undefined break target, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement, else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement, if expression statement, return contains undefined break target of statement with argument label set. Do while statement, do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression not. Expression not. Expression not statement. 4. var variable declaration list. Expression not. Expression not statement. 4. Lexical declaration. Expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5. Break statement. Break. 1. Return false. Copyright sign. ECMA International 2024 113. Break statement. Break label identifier. If label set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set is true, return true. If C contains undefined break target of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses. Case clause. Let has undefined labels be contains undefined break target of case clauses with argument label set. If has undefined labels is true, return true. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. If contains undefined break target of block with argument label set is true, return true. If contains undefined break target of catch with argument label set is true, return true. Return contains undefined break target of finally with argument label set. Catch. Catch. Catch parameter. Block. Return contains undefined break target of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has undefined labels be contains undefined break target of module item list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 static semantics. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. The syntax directed operation. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D. Capital C O T I N U E capital T A R G E a block statement with arguments iteration set and ECMA International 2024 115 breakable statement iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of iteration statement with arguments new iteration set and statement list item. Let as undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list item with arguments iteration set and if statement if expression statement else statement. Let as undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the first statement with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the second statement with arguments iteration set and if statement if expression statement. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and do while statement do statement while expression. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and while statement while expression statement. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and for statement 4 expression not statement 4. var variable declaration list. Expression statement 4. Lexical declaration expression statement. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration second. For in of statement 4. Left-hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. var for binding of assignment expression statement 4. For declaration of assignment expression statement for await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement for await. For declaration of assignment expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration second. Note this section is extended by an XB 3.5 continue statement. Continue 1. Return false 116 ECMA International 2024. Continue statement. Continue label identifier. If iteration set does not contain the string value of label identifier, return true. Return false with statement. With expression statement, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration second. Switch statement. Switch expression case block return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case block with argum and iteration second. Case block return false. Case block case clause assopt default clause case clause assopt. If the first case clause is present, then a if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the first case clauses with arguments iteration second is true, return true. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of default clause with arguments iteration second is true, return true. If the second case clause is not present, return false. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G, E, of the second case clauses with arguments iteration second. Case clauses, case clauses, case clause. Let has undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clauses with arguments iteration second. If has undefined labels is true, return true. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of case clause with arguments iteration second. Case clause, case expression, statement list opt. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of statement list with arguments iteration second. Return false. Default clause, default, statement list opt. If the statement list is present, return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of statement list with arguments iteration second. Return false. Labeled statement, label identifier, labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of labeled item with arguments iteration set and new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of block with arguments iteration second. If has undefined labels is true, return true. Return capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, of catch with arguments iteration second. ECMA International 2024 117. Try statement. Try block finally. Let has undefined labels be capital C, O, N, T, A, I, N, S, capital U, N, D, E, F, I, N, E, D, capital C, O, N, T, I, N, U, E, capital T, A, R, G, E, A block with arguments iteration second. If has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. Finally with arguments iteration second. Try statement. Try block catch finally. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A block with arguments iteration second is true, return true. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. Of catch with arguments iteration second is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. Finally with arguments iteration second. Catch parameter block. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A block with arguments iteration second. Function statement list empty 1. Return false. Class static block statement list empty 1. Return false. Module item list module item. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A module item list with arguments iteration second. If has undefined labels is true, return true. Return contains undefined. Continue target of module item with arguments iteration second. Module item. Import declaration. Export declaration. Return false. Point 4 function name inference. Comma 4.1 static semantics. Has name. The syntax directed operation has name takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. If as function definition of expa is false, return false, return whose name of expa, function expression, function, formal parameters, function body, generator expression, function, formal parameters, generator body, async generator expression, async function, formal parameters, async generator body, async function expression, async function, formal parameters, async function body. 18. ECMA International 2024. Arrow function, arrow parameters equals, concise body, async arrow function, async arrow binding identifier equals, async concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, equals, async concise body, class expression, class tail, return false, function expression, function binding identifier, formal parameters, function body, generator expression, function binding identifier, formal parameters, generator body, async generator expression, async function binding identifier, formal parameters, async generator body, async function expression, async function binding identifier, formal parameters, async function body, class expression, class binding identifier, class tail, return true, 4.2 static semantics is function definition. The syntax directed operation is function definition, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O.
Okay, it looks like there's
Definition of expa, primary expression.
there's only $12,000 crossing 9,000. So that's a lot less than whatever the total was. So I'm gonna do like a master place, and then I'm gonna organize these files. I'm gonna use like a lowercase q because I don't know. I don't want to like. I'm out of letters to use for like tagging things because I've tagged a bunch of other things and things are gonna have the same name and all stuff will get messed up. So I'm like tagging these with like lowercase q in the name or whatever for the thing. I'm gonna find them all 12,930, and then replace them. So I gotta organize the files. I'm gonna try to find the more complicated ones, put them up at the top of the list, and then work my way down to the easy ones. I still have to make the defines for the length for the arithmetic and the addressing, but I will do that after I try to organize things and get set up to just get this done and over with.
Expression instance of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression, Equality expression equals relational expression 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 bitwise and expression and equality expression bitwise or expression bitwise and expression bitwise or expression logical and expression and bitwise or expression logical or expression logical and expression coalesce expression head bitwise or expression conditional expression short circuit expression assignment expression 20 ECMA International 2024 assignment expression yield expression left-hand side expression equals assignment expression left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression assignment expression return false assignment expression arrow function async arrow function expression function binding identifier opt formal parameters function body generator expression function binding identifier opt formal parameters generator body async generator expression async function binding identifier opt formal parameters async generator body async function expression async function binding identifier opt formal parameters async function body class expression class binding identifier opt class tail 1 return true 4.3 static semantics is anonymous function definition expa the abstract operation is anonymous function definition takes argument expa an assignment expression parse node an initializer parse node or an expression parse node and returns a boolean. It determines if its argument is a function definition that does not bind a name. It performs the following steps when called. If as function definition of expa is false, let hasName be hasName of expa. If hasName is true.
I forgot about the sign types, so I gotta replace that stuff too. This will be more than 12,000 now.
Over
Most of the sign types don't involve addressing. That's usually unsigned. So that's just casting whatever to the sign type, because I needed like the sign bit for like right shifts to keep the top bit for bit arithmetic and stuff, whatever. So I like rename those also. This is so boring.
A Z E D capital E X P R E S S I O N capital A N member expression member expression identify name member expression template literal super property meter property new member expression arguments member expression private identifier new expression left hand side expression call expression optional expression return false 4.5 runtime semantics named evaluation the syntax directed operation named evaluation takes argument name a property key or a private name and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N return. Named evaluation of expr with argument name parenthesized expression. Expression assert is anonymous function definition. Expression is true. Return. Named evaluation of expression with argument name function expression. Function formal parameters. Function body. Return. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P a function expression with argument name. Generator expression function formal parameters. Generator body. Return. Capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital E X of generator expression with argument name. Async generator expression.
Okay, luckily, there's only 128, 126 signed size T type words, whatever, which are 32-bit, will be 64-bit and better. I'm glad that's not like 1,000 or something, or some big number. I'm really happy that's only 126. So I'm gonna like replace those and then whatever, keep going.
International 2024. Async function expression. Async function. Formal parameters. Async function body. 1. Return. Capital I N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S of async function expression with argument name. Arrow function. Arrow parameters equals concise body. Return. Capital.
And to close the compiler, pick back up.
A T E capital A R R O W capital F U N C T I O N capital E X P R E S of arrow function with
This computer is real laggy. I click on the folder and like it unclicks or something, then I have to click it again. I might need to restart. I don't know, something is wrong with this computer. It's acting up.
N capital A N D capital A.
It's probably because I've replaced across all those files and the Windows is like unstable and there's some memory leak or something. I hate this computer.
N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E of async arrow function with argument name. Class expression. Class tail. Let value be. Class definition. Evaluation of class tail with arguments undefined and name. Set value to the source text match by class expression. Return value. 0.5 contains, 5.1 static semantics. Contains. The syntax-directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains. For each child node child of this parse node. Do if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier opt. Formal parameters. Generator body. Async.
It takes like 2 minutes to build, so I will check this other computer and check back here in a minute. Because 2 minutes is a very long time. I'm gonna do something else. It's so boring.
Async function body. Async function. Formal parameters. Async function body. ECMA International 2024 123. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail. Class heritage art. Class body. If symbol is class body, return true. If symbol is class heritage, then if class heritage is present, return true. Otherwise return false. 3. If class heritage is present, then if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals concise body. If symbol is not one of new target. Super property. Super call. Super. Or this. Return false. If arrow parameters contain symbol is true. Return true. Return concise body contains symbol. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return formals contain symbol. Async arrow function. Async arrow binding identifier equals async concise body. If symbol is not one of new target. Super property. Super call. Super. Or this. Return false. Return async concise body contains symbol. Async arrow function. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals async concise body. If symbol is not one of new target. Super property. Super call. Super. Or this. Return false. Let head be the async arrow head that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. capital A, N, D, capital A, S, Y, N, C, capital A, R, R. If head contains symbol is true, return true. Return async concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies X. PT for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true, return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super, return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true, return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true, return true. Return false. 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, computed property name, return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return the result of computed property contains of class element name with argument symbol, generator method, class element name, unique formal parameters, generator body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method, async class element name, unique formal parameters, async generator body, return the result of computed property contains of class element name with argument symbol. Class element list, class element list, class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name. Unique formal parameters. Async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initializer opt. Return the result of computed property contains of class element name with argument symbol. 0.6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instanti. 8 function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, a function declaration with argument CNV and private env. Generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T I A T E capital G E N E R A T O R capital F U N C T I O N capital O B of generator declaration with arguments env and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of async generator declaration with arguments env and private env. 26. ECMA International 2024. Async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return instantiate async function object of async function declaration with arguments env and private env8. 6. To runtime semantics, binding initialization. The syntax-directed operation binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier, let name be string value of identifier, return. Initialize bound name, value, environment, binding identifier, yield, return. Initialize bound name, yield, value, environment. Binding identifier, await, return. Initialize bound name, await, value, environment. Binding pattern, object binding pattern, perform. Require object coercible, value, return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern, array binding pattern, let iterator record be, get iterator, value, sync, let result be completion, iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return. Iterator close, iterator record, result, return result, object binding pattern, 1. Return unused. Object binding pattern. Binding property list. Binding property list. Perform. Property binding initialization of binding property list with arguments value and environment. Return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding rest property. Let excluded names be a new empty list. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. Let excluded names be. Property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding name, value be return unused, else a let LHS be. Resolve binding name be return. Put value LHS value, 6.3 runtime semantics, iterator binding initialization, The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initializatio, N of binding rest element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. Environment. Let v be undefined. If iterator record is false, then a let next be. Iterator step value. Iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition. Initializer. is true. Then I set var2 named evaluation of initializer with argument binding id be else I let default value be evaluation of initializer 2 set var2 get value default value if environment is undefined return put value LHS v return initialize reference binding LHS v binding element binding pattern initializer opt let v be undefined if iterator record is false then let next be iterator step value iterator record be if next is not done then I set v to next if initializer is present and v is undefined then let default value be evaluation of initializer be set v2 get value default value return binding initialization of binding pattern with arguments v and environment binding rest element binding identifier let LHS be resolve binding string value of binding identifier environment let a be array create 0 let 0 repeat let next be done be if iterator record is false then I set next to iterator step value iterator record see if next is done then ECMA International 2024 129 if environment is undefined return put value LHS a2 return initialize reference binding LHS a deperform create data property or throw a to string n next set n to n plus 1 binding rest element binding pattern let a be array create 0 let 0 repeat let next be done be if iterator record is false then
I meant to hit run. I just built it. I gotta wait 2 more minutes. Dang it.
and environment deperform create data property or throw a to string n next
Any day now this is gonna be done. It should build and run perfectly fine. I don't know. I just want to check it. I gotta get to like sorting out the files and stuff.
binding initialization of function rest parameter with arguments iterator record and environment formal parameter list formal parameter list formal parameter perform iterator binding initialization of formal parameter list with arguments iterator record and environment return iterator binding initialization of formal parameter with arguments iterator record and environment arrow parameters binding identifier let v be undefined assert iterator record is false let next be iterator step value iterator record if next is not done then set v to next return binding initialization of binding identifier with arguments v and environment arrow parameters capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N return iterator binding initialization of formals with arguments iterator record and environment async arrow binding identifier let v be undefined assert iterator record is false let next be iterator step value iterator record if next is not done then set v to next return binding initialization of binding identifier with arguments v and environment 30 ECMA International 2024 8 6. For static semantics. Assignment target type. The syntax-directed operation assignment target type takes no arguments and returns simple or invalid. It is defined piecewise over the following productions. Identifier reference. Identifier. If this identifier reference is contained in strict mode code and string value of identifier is either eval or arguments, return invalid. Return simple. Identifier reference. Yield. Await. Call expression. Call expression. Expression. Call expression. Identifier name. Call expression. Private identifier member expression. Member expression. Expression. Member expression. Identifier name super property. Member expression. Private identifier. Return simple. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return assignment target type of expa. Primary expression. This literal, array literal, object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal. Call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Supercall. Import call. Call expression arguments. Call expression template literal. New expression. New expression. Member expression. Member expression template literal. New member expression arguments. ECMA International 2024 131. New target. New target. Import meter. Import meta. Left hand side expression. Optional expression. Update expression. Left hand side expression plus plus. Left hand side expression. Plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative expression, multiplicative operator exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instancy of shift express, ion relational expression in shift expression, private identifier in shift expression, equality expression, equality expression equals relational 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 expression, bitwise and expression, bitwise and expression and equality expression, bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, logical and expression and bitwise or expression. 32. ECMA International 2024. Logical or expression, logical or expression, logical and expression, coalesce expression head. Bitwise or expression, conditional expression, short circuit expression, assignment expression, assignment expression, assignment expression, yield expression, arrow function, async arrow function. Left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, expression, assignment expression, return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string. NBR. Computed property name. Assignment expression. 1. Return empty. ECMA International 2024 133. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Return prop name of class element name. Generator method. Class element name. Unique formal parameters. Generator body. Return prop name of class element name. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return prop name of class element name. Class element. Class static block 1. Return empty. Class element 1. Return empty. Async method. Async class element name. Unique formal parameters. Async function body 1. Return prop name of class element name. Field definition. Class element name initializer opt1. Return prop name of class element name. Class element name. Private identifier 1. Return empty. Executable code and execution contexts 9.1 Environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code, such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record.
JavaScript has Boolean types, like a Boolean, and you can't. It's hard to understand with the fan, but they have Boolean types or whatever, and I removed Booleans because they're stupid. I just kept it 0 and 1 for my engine. I'm gonna have to put a Boolean type in to meet the standard whatever. So mine's like I streamlined it to just work with numbers or whatever, and I I optimized the language and cut the fat, so I have to put fat back in to meet the standard. But it's complicated. I don't know. I can't just change anything with without having to change all of the things. I don't want to get into the technical part, but I don't want to give stuff away. It's complicated. I'm so annoyed. I can't just take stuff out and swap it in with something simpler. have to rewrite the garbage collection too. Because I turned off the assembly that I was using like last month or whatever when I found a backup and like checked stuff and ran it. And I had parts of that I didn't write in C. So there was like, I can't run parts of the code in 64-bit without the assembly. I'm not going to put the assembly in because this needs to be all C language. Otherwise I'd have to write assembly for whatever processor it's going to run on. I don't know if there's an echo. I hope there's an echo. So I like turn that off. I'm gonna have to like open those files again. And then like programming in C is stupid. I hate C. This is stupid. Programming with a language is dumb. I literally need to like just convert it and then deal with what I'm gonna tweak or whatever later. Because I faked floating point precision by just copying what they do, but I use integers, whatever. And I have a bit field for the number. And an encoding for like each type of number format it is. I don't know how I'm going to easily adjust this to 64-bit. Like, I'm gonna have to I can update everything to be 64-bit arithmetic, whatever, for like memory accesses. That's what I'm doing now. But the rest of the program, it's I can't just change the scale of the number. I'm gonna have to like physically rewrite more than I wanted to, I think. Because otherwise it's like everything's gonna get clamped to like 4 bytes. It's 32-bit. Unless I tweak a couple places. But once I tweak those, it trickles down to like a whole bunch of other places. It's overwhelming. So I'm going to just convert the addressing, so it'll run and work with 64-bit addresses. And it should be able to access more than 4 gigs. That's going to be fun. When I run it, I can make a test, make a large application that's bigger than 4 gigs. Because in 32-bit mode, it hit 4 gigs, and then I page it to my own little custom pager thing. But now I can like actually use more than 4 gigs. And I don't know, I'm gonna like, that'll be fun. So that's gonna be my what I'm aiming for and what I'm gonna look forward to. And then everything I'm not gonna look forward to, I'll do with it after. Because that stuff, that's not intertwined with the type, like encodings, I guess you'd call it, and the formats, and I think I might need to just meet the standard and then like disable. I don't know. I'm gonna figure out later. I thought like if I put the number 8 instead of 4 for like to scale it to 8 bytes. I could do that everywhere, but I can't because things will break. And some things are like really tied together and they're like stuck to the number 4. And once I change that to an 8, things are gonna break. So I'm going to convert the address first. I'll get it running. I'll make the video game test. I'll leave everything as it is. I just need to get it running as 64-bit, and I'll do a little demo, whatever, and then to make the rest of it like 64-bit operations and everything, other than the address. It's gonna take work to like I'm gonna have to like rewrite a whole bunch of stuff. It's a lot more than I want to do. So I'm gonna I have notes on paper too. I'm gonna have to find my notes and pull them out. I'm gonna have to make new notes. So I'm gonna like replace, get the address space, and then save any of like the updating and modification for later. So I'm gonna like replace whatever, I don't know. I'm gonna like organize these files first by complexity, and then yeah.
Value of an immutable binding. BFS is true. Throw a type error exception. Return unused. Note an example of ECMAScript code that results in a missing binding at step 1 is function f eval var x equals delete x 0 ECMA International 2024 137 9 1 1 1 6 get binding value n s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec, 1 1 1 7 delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 1, 1. 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9 has superbinding. The has superbinding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 1, 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1. 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17. Additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 1, 1, 2. 1 has binding. N. The has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property binding object n. If found binding is false, return false. If envrec is false, return true. Let unscopables be. Get binding object add at unscopables. If unscopables is an object, then a let block be to Boolean. Get unscopables n be if blocked is true.
I think I'm going to...
1, 2. To create mutable binding.
I think I'm gonna find all the signed-ins, because there's only 127 of those. I will do those first. And I will feel like I've done something, and I'm gonna actually have to do something. Oh my god, 7 days. That was way too optimistic. I'm gonna do it though. 7 more days, I got this. Or 8 days? I don't know, I have 7.8. I didn't bite off more than I can chew, because I did this like 7 years ago. 2018, however many, it's 2025. I'm not in the mood for thinking right now. When I'm in the mood to actually think, I'll be able to tackle this, but everything's just so bloated. It's just code everywhere. Now I write code with macros and stuff, and like it's all contained and like organized. This is like spelled out and expanded, and I can't just like make macros and like simplify it. So there's no like KISS, keep it stupid simple. I can't keep it stupid simple because I could like break something by trying to put things together that are making a macro, and then if I miss an argument or like I don't know, I'm like screaming inside my head. I'm kind of annoyed with myself. So I'm gonna do the assignments first because there's only 127 rows. I'm gonna get those done, and then I'll get like GarageBand and
Unused, comma 1, 1.
play a little sound effect. Man, something is up with this mic.
DNVREC takes arguments n, a string, and s, a boolean, and return.
It's not the symbol, whatever the thing is that they hit with the hammer, the big whatever you call it.
Whose name is n, the property should already exist, but if it does not, the result depends you. Upon s, it performs the following steps when called. Let binding object be envrec. Let value be has property binding object n. If value is false, then if s is false, return undefined. Otherwise, throw a reference error exception for return get binding object n, 1, 1, 2, 7. Delete binding n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object n. 40. ECMA International 2024 9. 1. 1. 2. 8 has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has super binding. The has super binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, turn undefined, 1, 1, 3. Function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope.
I think it's playing, I don't know. I'm gonna like do the 127, 100 something, however many it was, assignments, and then I'll play this sound effect. That's that'll be like my positive reinforcement to like keep going. After that there's after I get those 127 signed in, so I'm gonna get to the rest of these files. I can't keep taking breaks. I'm gonna have to do something and stop stalling. So I'll do those signed ins first. Replace them and then tag them and then everything else after that. I don't know why it's sent louder. Try turning it up from here. It has to be like wow, like pop your ears loud. %. See if that's louder. Okay, that was louder, but not enough. Maybe like try 400%. That was the wrong button. I clicked the wrong one again. It's not loud enough. I want it to like hit right above the, what is that, -4 decibels? Or I don't know, whatever. I can't read this program. This should be louder. Possibly louder. That's close. Just a little bit louder, and I'm good. Then I'll actually do something. I think that's loud enough. I want to like exaggerate the lows a bit though. I'm done wasting time. I'll just keep the original sound and leave it. That's good enough, whatever.
Method invocations from
I'm gonna replace this stuff then.
Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide this binding. Note: object environment records do not provide a super binding. Field name: value, meaning this value. An ECMAScript language value. This is the this value used for this invocation of the function. This binding status: lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object. An ECMAScript function object. The function object whose invocation caused this environment record to be created. New target. An object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support methods listed in Table 19. Table 19. Additional methods of function environment records. Method purpose: bind this value. V. Set the end record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if the this binding has not been initialized. Get superbase. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms: 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 3, 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 3. 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec, his binding status, is lexical, return false. If envrec is undefined, return false. Otherwise, return true. 1, 3. Forget this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 3, 5 get superbase. The get superbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert: home is an object. Return home, 1, 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMAScript script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals. Clause 19. Properties of the global object, and for all top-level declarations. 8, 2, 9. The 8th of February 2011. that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records. Get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations, and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, and object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024. 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string val UEN is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms: 1, 4, 1 has binding, n, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, return true. Let OBJREC be envrec. Return OBJREC has binding, n, 1, 4. To create mutable binding, n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create mutable binding, n, d, 1, 4, 3 create a mutable binding, n, s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, throw a type error exception. Return DCLREC create a mutable binding, n, s, 1, 4, 4 initialize binding, n, v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, then a return DCLREC initialize binding, n, v. Assert. If the binding exists, it must be in the object n, the environment record. Let OBJREC be envrec. Return OBJREC initialize binding, n, v, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. If the binding is an immutable binding and s is true, a type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, then a return DCLREC set mutable binding, n, v, s. Let OBJREC be n.
Right now, I have the engine has like 4 types: function, number, string, object. A 32-bit number is 4 bytes.
Either a normal completion containing an ECMAScript language value.
Really, JavaScript has more than 4 types. It has a Boolean, whatever, more than 4 types. But I broke it down to 4. I got rid of the bools, and I creatively encoded things to make it work with 4 types, and cut the fat out.
DCL rec get by.
There are new types that they added, like a big int, and that's not floating point. That's like it's like big number support. That's actually kind of useful that they added that. It's actually kind of cool, and I would have used that for some of the stuff that I was doing, but the current JavaScript implementations, they're so slow that I still would have had to rewrite or make from scratch whatever my own engine. And I'm rewriting this so I don't have to write a new one. But by the time I'm done with this, it's basically, it's gonna be like writing a new one from scratch in the end. And then just using the old engine I have as like a skeleton, whatever, to like know where to place and organize things.
It performs the following steps where
But since I used 4, I use 4 as like a magic number for like everything.
return false.
That was a huge mistake. I should have separated things, because now I have to organize and figure out why the hell I'm using the number 4 and what it holds relation to into whatever data structure that it's accessing.
an object.
So I have like the addresses. I think I need some water, but I'm gonna focus on only the addresses, and then I gotta think about how I'm going to tag the numbers, because where I'm using where I have 4 types, whatever, and I'm relying on the byte size, but it scales to another number, and it has the data structure, whatever, so I'm gonna need 8 types in the end to support big int and symbols. I think they added symbol types.
Lexical declarations.
And it changes the control flow, whatever. I can't fit all the logic. I'm gonna have to like step it or whatever, or like add another layer of memory, which will slow things down a teeny bit. But if I expand things, everything will get slow, because it'll have to run through more code overall. I'm gonna have to like test some stuff later. But where I'm multiplying it by 4, if I scale that and I use the size t, whatever, it means I would have 8 types. But the whole thing's set up for only 4 types. So I would need to track down internally where I'm checking for 0, 1, 2, 3. because that's for whatever. Because 0 is included. 0, 1, 2, 3. Not the number 4 itself. Like base is 0, whatever length. That's a lot of work to check all that down. And it's gonna take up calculator.
147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined, return is extensible. Global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values. True, enumerable. True, return true. Return false, 1, 1, 4, 1, 7 create global var binding. N, D. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes environment record and records the bound name in the associated list. If a binding already exists, it is reused and
it takes up 8 times more space. Because I can't just throw the number 8 in there. I'm gonna have like a bunch of like padded bytes that nothing's being used for. So I'm going to tag the numbers because I need a number and I need like a scaled number. I need to like identify I should probably make a different number tag based on like the module it's being used for, instead of trying to like tag all the related things and simplify it. So I'm not going to tag the numbers. I'm going to leave those all tagged with the current tag, and then only tag the new things with the letter A in the tag name. I'll get all the addresses and then I'll deal with the numbers later. I have to like any change is gonna like affect the whole thing. So I'm going to do that. I'm going to just focus on only the addressing. I'll get it to run as 64-bit. I won't get 64-bit numbers or like other like 64-bit related things other than more memory. But I'll be able to run like tests and stuff. I don't think for graphics and stuff that they use 64-bit numbers. I think it's usually 32-bit. Or I think it depends on the floating point in the driver and what you set it to. I'm gonna tag the addresses and then figure out whatever later. I hope there's not an echo, because I can hear an echo. And I have the headphones that I have in my ears turned down. The mic shouldn't be picking it up. It might be. I don't know. I'm gonna just try to tag all these addresses so after I get the site numbers. I need to just pick one thing and stick to it. Why can't I hear myself?
The value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert S is true.
Testing. Test. I don't know, something's up. It might be up with the software. I have to check the stream in a minute. I hope it's not double echoing everything I say.
Binding for an env rec is an uninitialized binding.
Because it'd be doing that for a while now at this point. It did it the whole time. I'm gonna try to focus whatever. I'm gonna get these signings and then the addresses, and then I'm gonna stop thinking ahead because I can't. I'm gonna have to do something before I can even get to the rest anyways. And it's gonna be more complicated than I want. Just have to like deal with it on the go, I guess.
Record, and N2 is a binding that exists in M's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C135111153 has this binding. Concrete method of a module environment record. env rec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 5. Forget this binding. The get this binding concrete method of a module environment record. env rec takes no normal completion.
Okay, lastly, this is like the last whatever, like
Import binding.
thing I'm trying to like think about whatever. I don't know if I want to
Takes arguments n, a string, m,
use 8-byte alignment if only 6 bytes are used for the addresses. I might be able to pack everything to 6-byte alignment.
It performs the following.
It's not going to affect the speed on the newer processors because unaligned, or like the mainstream processors, unaligned accesses are like they get absorbed the time it takes, whatever. So there's not much penalty for unaligned memory accesses. And 6 bytes would save me 2 bytes, or 8 bytes would be every time. But that means I'm gonna have to cast, and then that top bit of the 6 bytes, I think it depends on whatever it's running on. I don't know if it's compiler specific or OS or kernel or whatever, somewhere in the software layer.
International.
That top bit, I think, has to be carried to the other 2 bytes. So if the top bit's set, then the 2 bytes above it and the address have to be set to all like all on or all off to match that top bit.
Or null, and
So I think I'm going to wait on that too. So I'll just tag everything with the little A or capital A, whatever. And then later on, I might attempt to like I don't know if it's worth the effort though to save 2 bytes. It would add up to like a lot of space over time, the more memory use. So I'll wait on that too. They should have just designed 8-byte addressing
defined and return.
to actually use all 8 bytes. Instead they just did 4 byte and added 2 bytes. So I'm going to do the sign-ins. I'm gonna take a break where I got a thing, and I'm gonna come back and start on only the addresses, I guess, because I want to do like a couple things as I was going through, but I need to wait because I can't make like a definite choice. Because if I do, I could like shoot myself in the foot, metaphorically, later. If I do something like all over the place, I have to undo it. It's easier to just leave it and then make another pass later than make a mistake, or not a mistake, make a choice that is a bad choice that has to be undone later on and have to backtrack. So I'm gonna get the signed-ins, whatever, tag those at 100 something of them, get that over with. I'm gonna go, I gotta try to find my notes or whatever from last time I wrote this. And then I'll get the addresses, and then that's gonna take like 7 days, hopefully. Just like getting these addresses. And then I'm gonna, whatever else after that can wait. I'm gonna do the not speed test, make like a graphics test to show it works as a game, or it should work for making video games. And then I'll deal with changing anything internally in the engine. I don't know. Saying that out loud, I'll just go with that. I want to make a choice and just do a whole bunch at once, but I'm not going to backtrack. I can't take backtracking, it sucks. Let me get the sign-ins now, and then, I don't know. Figure out from there.
It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV, names, 2, 1. To resolve private identifier, privy NV, identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy NV be privy NV. Assert outer privy NV is not null. Return resolve private identifier. Outer privy NV identifier. 3 realms. Before it is evaluated, all ECMAScript code must be associated with the realm. Conceptually, A realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24:52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3.2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, b set global obj to ordinary object create intrinsics assert global obj is an object. If this value is undefined, Set this value to global obj. Set realm rect to global obj. Let new global env be new global environment. Global obj. This value. Set realm rect to new global env. Return unused. 3.4 Set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desc return global. Point 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this spec. Bifurcation. Context has been suspended.
In places where I use like I'm pretty much stuck with 4 bytes 32-bit being like the smallest like type size. So I want to try and not define anything in this whole program as a 32 a 64-bit number, because then I make the smallest type size, the native type size, 64-bit. I don't know. I need to like change the program without like changing it or breaking it. but making it support more stuff. I'll have to break something at some point and then fix it. But if I do only the addresses for now, that's all like isolated. I won't have to worry about things breaking. I'll get it running. I'll do like a demo with OpenGL or whatever. Whatever one's like easiest to get going and running. And then after that I'll have to break something and rewrite some stuff to put new stuff in place.
Next, it performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution.
So I think I'm actually going to tag those types now. But I'm not going to tag them as machine word. I'm going to tag them the signed ins, whatever. I'm going to tag them as I have to tag them as I'm just going to get going, and if I have to backtrack at some point, then I guess I have to backtrack.
Assert. env is an environment record. If the source text...
Because some things are scaled by the byte size, but it really has nothing to do with the byte size. I just used the number 4 as the base number for like 4 options, whatever, and I stuck with 4. So once I make it 8, other things are going to break because they rely on 4. But not like address-wise. I mean like the way the data is aligned for like the values that it holds within the bigger chunk, whatever. I'll just like keep going and replace stuff.
4. Note the result of resolved binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert. envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are schedule, ed for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host calge of callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 Host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG.html specification, https://html.spec.whatwg.org/ For example, uses the host-defined value.
There's 125 signed ins.
Meaning callback.
I'm gonna replace them with a different define whatever, tag whatever, that'll define it as like
By hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record.
this is confusing.
V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback, v, arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback, v, arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record.
The number part can't be 64-bit yet, but it needs to be stored to the 64-bit value field now. So I need to keep the numbers as 4-byte for some things, but it has to be stored to the 64-bit value. And it's being casted, so I don't want, if I cut off the upper 4-bit bytes when it's supposed to be a 64-bit value, I'll lose that data at the end. And I have like shift operations where like you shift by number of bits and I cast it to unsending for 4 bytes. I need to cast it to I guess 64-bit, like an unsigned log long. So it won't like truncate the value because I'm using the shift macros like for some of the number operations, but also for some of the addressing, so there's like overlap. Okay, I think I'm gonna replace things first with the new whatever size T is of the build, the common register size, address size, and then after that I'll go through and I'll have to pick out places where it's only supposed to be 4 bytes. Like specifically, I'll probably like give it a name based on what like file or like module it belongs to. I'll keep like a list of them and then figure them out later on how to track down where they're at, because it's going to end up truncating the data at some point. Like it doesn't matter if there's data loss, if it's only using the bottom 4 bytes, but it does matter in some places where it needs them. I'm gonna think for a minute and then whatever. And I'm gonna replace these and then replace addresses, whatever. I don't want to like make new macros and have to like track everything down and keep track of 2 separate macros. And if I truncate the data and there's data loss, I might not catch it right away if there's an issue. And if I don't catch it right away, it'll pop up later and I'll have to like dig in and waste a whole lot of time trying to figure it out. I think everything needs to just expand to a scale of 8 instead of a scale of 4. And then I'll have to like find where it's not supposed to scale and then pick a smaller number like 4 or whatever the number needs to be. Either way, I have to do like multiple passes. But if I do it the second way, where I just scale everything, because I need 8 types anyways. It's gonna take up like 8 times. Yeah, 8 times more memory because of how it's set up, whatever. I think I'll do it. Because at least then I'm not, I don't have to worry about data loss. And then I can deal with bloat or find like where something's scaled and it needs to be truncated down to like a smaller type because it's only using part of the field to a smaller number later. I'll do that. So I'm gonna like update everything where it's using a type size of 4 to type size of 8, knowing that it will expand things to bigger ranges and break stuff, because any place where I check it won't break stuff actually, it just won't be able to use what's above the 4. Because I have like 4 types right now, so if I pass in 5, I have some checks to make sure the number won't be greater than 3. Nothing's gonna end up being bigger than 3 anyways. It won't be 4, 5, 6, 7 because it's only 4 byte, or it's set up for that, the types. I have to physically add more options for 5. I have to extend some tables and some switches to have more than 4 for it to even do that. And nothing goes above that right now. So I'll do that then. I'll just use a bigger type and I'll deal with picking what to truncate to a smaller number of choices later after. Because at least then there's no possible data loss or truncation of the value itself. It just won't use the full value until I either update it, change the code to use a bigger number, or I update it to use a smaller number, and then I can save memory. So that's what I'm going to do then. I just need to think for a minute. Because both those options suck. But I can't easily...
R, 7.2.
I can't like easily just replace a bunch of macros and adjust stuff without breaking something for certain. BRB.
In a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster mus have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1: programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2: the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the T execution field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when per agent resource accounting indicates that the agent is runaway. Note 6: all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7: an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9: forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent